We're going to go into our first demo session. So I'm going to hand over to Mark from Finexos.
Be the first presenter on this really important event. I'm Mark Fisher. I founded Finexos back in 2017, following two and a half years of research into the credit markets, credit scoring, and why so many people were using very expensive lines of credit. I did forecast back in 2016 that it would just take one major financial event and millions more people who never had a problem with their finances would find themselves in financial difficulty. Unfortunately, we didn't have to wait long, and the pandemic hit in 2019, followed then by inflation, increase in energy prices, and of course, higher interest rates, which have affected most of my circle anyway. Finexos is all about creating better outcomes from making better decisions. Okay, and we've used and built an AI over almost a decade now to prove that by using behavioral analytics and real-time data, we can reduce risk, cost, and default rates for lenders, borrowers, and society. The three key areas that we want to focus on today, and I'm very excited to present the results from the Digital Sandbox, is that we all agree, I believe, that default rates are on the increase. Lenders are turning away millions of borrowers unnecessarily because the metrics that we're currently using in some cases are outdated. And of course, if you want to retain customers, you've got to give them a better rate, otherwise they'll go somewhere else, right? So we set about building an entirely new platform, AI powered. It's called Fiola, the Financial Intelligence Online Assistant. So what we needed to prove here was that we could use data from any source, be it transactional data, through open banking or direct feed, origination data, telco. So pretty much any data that you're currently using to make decisions can actually be used in our risk engine. It's based on the behavioral profile. So we're measuring how well people are managing their money, managing their credit, and making repayments. But one of the key factors and really innovative points is here that we've removed the use of PII. So we don't know who you are. We don't believe we need to know who you are. And that should, by virtue, increase financial inclusion for those people who are typically excluded. And I'll give you examples. I've met with lenders who typically will not look at single parents, will basically look at postcodes. If they don't like where you live, they may not decide to lend to you. And that's really unfair in my opinion. So we engineered the system so that it could monitor the behavior within the account and calculate a new metric around their ability to do that. But we've done a huge amount of innovation. We've reduced the cost of using ML by automating it. So we do not need huge teams of data scientists. We can actually reprioritize factors automatically. And it doesn't take 3 months to do it. It's done in less than a few seconds. So the financial capability score is our proprietary metric. It's a measurement of how well somebody manages their money, their outgoings, and their credit on a monthly basis. And it's highly indicative of default. So we specialize in detecting the factors that would create a default. Why? Well, we need to get a decision made really quickly in most cases. So we have provided you with a platform that is API driven, that can integrate quickly with any platform. It helps the borrower through the onboarding process. We can then take a clear look at all of the various data sources that you're using and how we can calculate that score for you. The big advantage here really is the fact that it reduces cost for the lender. So we're helping lenders to price their risk more effectively, assess their loan books in real time. We're not waiting 6 to 8 weeks for a credit score to update. We can safely approve more customers because we can determine the default and probability of default rate. We've removed PII to drive financial inclusion. And if you're focused on consumer duty, we've pretty much covered most of those areas for it as well. This is the benefit of using the Digital Sandbox. We took through the lending club data within the sandbox, 900,000 accounts analyzed. They had a default rate of 28%. Our system would have been able to detect 58% of those defaults at the point of origination. And that's a median between the FICO score at 72% and Vantage at 43. We would have said yes to 96% of their loans and improved the balance sheet overall by 17%, which in fact was a $2.4 billion saving to that lender. Now, we don't consider Lending Club to be a massive lender. That's quite what we'd consider maybe a medium size. So if you think of a bank or a bigger lender, the savings could be enormous. Following that, then we took the results and we applied that to live data in the UK market. We've also used data sets from Canada, the United States, LATAM, and the UK. What we were able to do on this case is for a lender in the UK, relatively small book, 70,000 loans analysed, but we were able to detect 84% of their good loans, detect 39% of their bad decisions, and save that lender in the region of £6.5 million, which is the difference between survivability and failure. We then took our system to a lender that has an AI credit scoring platform already in place. And even though they'd invested heavily into that, we were still able to improve default detection by 35%. And that is akin to the power of the FCS metric, which is innately able to determine if that customer is going to default. So it's very easy to use our system, and I want to give a shout out to our partners as well at Naya One, because they provided us with the sandbox. So if you want to test this before you want to buy it, you can head over to the Naya One sandbox. You can synthesize your data. You can use real data. It's all anonymized, so we don't use any PII. It's very, very safe, and produce a set of results that will be relevant to your business. So any questions from the audience? I thought I wouldn't be greedy on the first go.
Did I see a hand up over here? Thank you.
Yeah, so, sorry, my question is really about the kind of the inclusion or exclusion of the PII data. So I think there's a kind of like a balance perspective, because if you exclude the data about that person, are you then potentially getting the issue where you're not aware of a bias that exists or is created?
Yeah, it's a great question, actually. So we believe that your personally identifiable information is your KYC function. What we're analyzing is your ability to service the credit product, if your behaviors match with a customer that is going to pay you back, and then feed that through to the next stage of the origination process. So we're removing bias from the PII, but we're also looking at the transactional labels within the data so that we can actively remove bias at that stage as well.
Hi, in terms of how would this replace an affordability model calculation?
It's another great question. It's actually a really detailed affordability model. It doesn't replace it. It analyzes all of the transactional data. Up to 3 years, we can use much lower data sets if required to provide very sensitive affordability metrics. So the idea is that we are analyzing every single transaction within that data set over a 3-year period or less. So we are really focused on essential expenditure, non-essential expenditure, categorization, ensuring that that money is there to repay the credit product. And in a term like consolidation, it's really important that you do that, because some of the savings from the consolidation can boost the cash flow.
Just 1 minute. Also, what I didn't remind people as well, if you're on the virtual line, you can ask questions in the Q&A. They will be moderated. So if you do have questions, please stop on your minute now. Edgar?
Hi, very interesting solution. So I think my question is going more to the end result, the outcome, the score. Will this be explained for the end user? And also, which barriers did you find to develop these to get it right, and how do you know it's right?
Yeah, really great question again. The quality of data was the biggest barrier. I'm going to be really honest. The quality of data when we started off 6-7 years ago was really poor. That has actually improved. We built our own categorization engine in-house because we had to. And when we started analyzing the labeling on the data, we were actually able to see that there's huge improvement in the efficacy of the score. So more work is needed around that. In fact, I would advocate something like a rating system for data, because not all data is the same. And the better we use that data, the better the outcome for borrowers and decisioning.
George?
In one of your use cases, I think it was the Canadian data set, you said you were able to identify 39% of their bad loans. I want to focus for a second on this remaining 61%. And how much do you know about the reasons why? Has this lack of identification been built into your models thereafter? Do you know anything about why the this data was not identified? Thanks.
Yeah, I mean, I could. This is a UK data set, actually. Just on that point. Okay, so the detection capability of our algorithm actually jumped by 300% on that data set, because they had so many defaulting customers. So we could actually determine more factors. So the whole idea is that the poorer the data set in terms of default at the earlier stage, the better, because we're training the algorithm to detect those features. And then we're subcategorizing the features as well, so that we can determine what the key factors in the default are. And we've trained the ML to automatically reprioritize those factors depending on what market we're operating in, where the nuance might be completely different. So it's continuous improvement. What we've been able to do with the digital sandbox data is actually empirically proved that the FCS metric outperforms current metrics that are used in the market now. And if combined with a credit score or an internal metric, you can actually start to improve your decisioning capability pretty quickly.
Right. I think we've got a question online.
Yep. So question from online: how does this product cater to customers who are mainly using cash?
Well, we're as you see, we're open banking driven. So with cash, it's very difficult. But based on the evidence that we've seen in other countries where you can use a telco data or some other form of alternative data, and if people in those cases don't even have a bank account, cash isn't particularly relevant because we can use alternative data sets in that situation. But it's ongoing improvement, as I say, it's development. It's taken us almost a decade to get this far, but it's in the plans for the next stage of development. Hopefully that answers it.
I think we'll go for one more question.
Thank you. The data set which you talked about, I noticed majority of them are in the global north. Are you looking at some testing on the global south, specifically like Africa and Asia? Thank you.
Yeah, that's a really important question for me. I'm traveling to LATAM pretty soon because that market as well could do with some technological advancement, although they are very well advanced in terms of open banking and payments data. The idea is that we want to use all available data to be able to make better decisions. The product was actually designed to work in a mature economy where people were over leveraged, and in an emerging economy where people need access to credit. So this is truly a global product that we've developed here. So Africa 100% is part of the overall plan to help people access credit safely there as well.
All right, that was a lot of questions, Mark. Well done. You put on the spot there.
Thank you.
So give it up to Mark from Finexos. Okay, next team. Oh, what's happening? Yeah, that's great emceeing by me, I think. So now I'm going to hand over to my life kit, and we've got Romano Toscano.
Thank you. Thanks all for organising this. Also, special thanks to Etsy, because I think we were not the easiest one on sending the presentations in time. We started this company 3 years ago with actually a bit of a different mindset. So we were thinking that everybody has a different score than only finances. So we looked at, can we include other data points and a lot of other data points to actually build a more rounded index based on data points. So as the previous discussion and presentation showed, there's a lot of alternative data available, but we want to take it out of credit and we want to use it actually in different forms. So we use other alternative data sets. So currently we all know roughly how the financial services are built up. And it's mainly based on financial models. How good are you repaying back your loans? What do you do with your loans? How frequently do your credit history? other alternative data lit from the other presentation. And we do that through a different model, because the problem is, if you're, for instance, say you're older than the current credit models, you can't get a mortgage anymore, but everybody turns to be older, healthier, living longer. So we want to get like a rounded model of everything, but also for people that actually don't have credit, to enroll them in the system. So can we build a system that, based on health data, environment data, will data, actually gives some kind of index to people, which we can use to build for instance, credit. The issue with that is, how do you do that? So how do you take data points that are not financially included into an index? So we start doing it with research. So what models can we use? What data can we add, and which data is actually relevant? There's a vast amount of data available, but not everything is correlated to your finances, for instance. So the model that we started using it is actually the model of Maslow. So there is one big model currently in the world, that is the pyramid of Maslow. So all the human needs are roughly captured in that index. There's a bit of discussion if it's 7 layers, 9 layers, and what the purpose of the layers are. There's more models. So we looked at all these models, and we tried to get all the data points from those models into our system. So do you breathe? That's a 0, or that's a 1. And then, do you feel social big? Do you have issues? Are you traveling a lot? Do you do the right steps? And then we see which of these data points can we actually use, also to make sure that it's actually a solid system. So the result is that currently the model is better at predicting defaults for unsecured lending than any other model that is. And that is quite clear, because there's a clear correlation between health and credit. So if you have a lot of stress in your life, that normally comes from credit, or it reflects on credit. If your work goes wrong, there's clear correlation in that. The correlation between environment and world is a bit smaller, and the index of the world is really personal. So we have a system that does it on public data sets and individual data sets. So we can index streets, we can index households, but we can also index countries. So we are currently also building a model that says, what are the data points that are different between, for instance, the UK and the Netherlands, and what's it going on? What we're trying to do is then go to lenders, but also go to the experience in the world and say, listen, you would probably give this person this index or this score. Because we have an alternative index score, can you offset some bad credit points for a healthy lifestyle? That turns out to be pretty accurate. It's also really interesting to do this, for instance, in a health situation where people can actually go to the hospital and then just give that data, which then actually shows a broader image. So what you see here is that a person has 695. If we add the VIA score to it, based on public data sets, you get actually a correlated index of 710. So while you actually were neglected for this loan, based on this index, you actually would get a loan, which is quite interesting to see. It also helps really in countries where there is cash, because you can actually, as long as you have the public data sets, or if you have a smartphone, you can actually start underwriting people that don't have access to the credit system, because you can index them on air quality, sleep patterns, behavior of the streets, etc., which is quite an interesting way to do it, I think. Who benefits for this? People with thin or no credit, the aging population, what I said again, but if you can't get a mortgage anymore because you're like 45, you should get a mortgage because you have a healthy life. Younger people not in the credit system. So the credit system starts at 18 years old. Everybody has a smartphone at 16. So you were able to underwrite people into the system when you're actually younger. Expats, because you can move this score. So one of the big problems also, if you move from country, your credit score doesn't move with you. Your VIA score can move with you because you have alternative data sets that are really into you. And it builds a global index, which I think for consumers is also interesting because it's transparent. I'll show it in the last screen, that you can, as a consumer, actually know what data points are used from you to actually calculate your credit. A lot of users say, you know, you have a credit score, but what does that actually mean? Which data points are into that score? So this is a bit, you can read this all later on. So this is where we're doing it now. We did it in the US. We're building it actually in Brazil for a big retailer. We're now getting into the United Kingdom. The challenge we have with the digital sandbox is there's not a lot of health data in there. And our model really is based on health. So there's quite a lot of transactional data from data in there. And we're now working also with the FCA on how can we get alternative data sets that are not in there to actually start calculating this. So that's a bit of a challenge, but I do think that is coming. There's so much data coming, and I think the organizations like the FCA and the Sandbox are great for that to do that. It runs in the Netherlands. In the Netherlands, it's predominantly used for health. So can you determine things the other way around? If you have a bad credit, do these people go more to the hospitals, and what are the data points that are actually triggered? And can we help these people getting a better lifestyle? Let me just see if this is an interesting, sorry, is it this one? Yeah, this is an interesting slide, so you can see what are the correlations between credit, health, environment, and world. As you see, the biggest one is health to credit. Credit to environment is a bit smaller, and world is the smallest. Although, if you go to an individual level, you really can see that if the stock market crashes in New York and you're a trader, that has an effect on your stress, that has an effect on your living, that also has an effect on your FIRE score. I want to end with this slide because I have 30 seconds. So this is a bit of a look into our system. You can see all the data points that we have. What is really important for us is that it's completely transparent for the banks and the institutions that use it. How is this score actually built? So we don't just come up with a score, but what are the data points under there? How is it built and how does it work? What is also interesting, you can switch off certain points which you don't want. So if you say, I don't want to do this on a postcode, or I don't want to do this on a specific drinking data points, you can switch that point off and the score automatically gets recalculated on the spot. I think I should hear a gong.
Okay. Before I open the floor for questions, I did notice there was something wrong in your presentation.
Really?
On the Maslow's hierarchy of needs, now they've got Wi-Fi at the very bottom of the pyramid. So you need to probably update that for future presentations. Yeah.
Thank you for that.
Okay, so
Wi-Fi is an important need.
it's right at the bottom. Right. That's why I started with the housekeeping connect to the Wi-Fi. Okay, so any questions in the room?
Okay, so how do you make sure that the VIO score, because of all the parameters it's based on, how do you make sure it does not exacerbate? It's about inclusion. How does not exacerbate a bad credit score, which typically may be due to some of the social constraints and some of the economic constraints that people with bad score have. The reasons that you see what I mean?
Yeah.
How does it make bad things worse?
How do you make?
How does it not make bad things worse? The people who are in need of credit and they have bad credit score.
Yeah.
They have bad credit score precisely because of some health issues. They have to foot bills.
Good question. That's always, I think, the challenge with systems like this. You can use it both ways. So what we're trying to do is, if you have a bad credit and you have a bad line or bad health, that is normally connected to each other and you can't do anything with it. So you're in a circle that's dragging you down. What we show is, if you improve certain points in this index, which you actually can improve, then you might be able to come back to the system with things that you actually control. If you have a negative credit score, that's like, well, okay, well, you need to get a credit card, pay it off more regularly, but that's quite abstract. If we tell you need to do very simple, more steps, then it actually is a tangible thing that you actually can do. So it's a good question. These things always work in two ways. If you have a bad credit, but even if you have a good credit, it's given to you on a moment, and then 3 days later your life crumbles. For a bank, that is like, that's a bad sign. For the person that has that credit, it really doesn't matter. So it works in two ways. Therefore, I think the ability to switch off certain fields for lenders are really important. So you can say, you know what, we don't want to take steps or this health feeds into consideration, but we still want to use air quality and other things.
I think we have a question in the chat.
Yep, so this is a question from online. How predictive is ViaScore of outcomes like loan performance?
Also a good question. So we're just starting in the UK because the thing with our score is every individual in every country is different. So the behavior of people in the Netherlands is completely different than people in the UK. What we tested is that it's 20 to 25% better in the UK on unsecured lending. We haven't went to mortgages or bigger loans. That's not the target value we tested. But in the UK, it is better than anything for unsecured lending up until £500 a month. We're trying to build this country by country, segment by segment. So health is a different one, credit is a different one, mortgage is the big one, but I think it's also the most difficult one to get into to get this adopted.
Okay.
Few more.
Hi, you mentioned about health data and everything else like that. How do you get the health data? Because obviously open banking is great. It's not the silver bullet, because open banking will tell you that I'm going into Tesco's Wednesday, Thursday and Friday spending £5.49 and you're taking an assumptive guess that I'm doing a meal deal. I could be a raving alcoholic. You're not getting this data from Tesco. So how do you know that if I've got a drinking habit or a smoking habit?
Yeah, so we have two versions. Let's see if I can get to that slide. Good question. We have two versions. We have one that's based on public data sets. So there is a lot of census databases available in countries, which actually goes to currently household level. For instance, in the UK, it's a bit difficult now, but in the Netherlands, you can go to household level on the census level. So we know on a household if there's problems with loneliness, drinking, et cetera, et cetera. With open banking, we don't get that data, but we ask the clients to give access to their open data and their health records on their phone. So Apple Watch or Apple phone. You can see that they're drinking, but there are certain points in that data behavior that you can see what things are going on. With open banking, you can see, for instance, if you go to Tesco's and specifically use that amount. Drinking is a very difficult thing, I think, to get in a public data set, because you don't want to really go punish people based on drinking, I think. But if you do that on a household level, on a street level, you can for sure see patterns in certain areas, which actually are predictive for a default on a loan, on a street level or even on a municipality level.
Okay, we're just out of time for Q&A. If you've got any more for Romano, please get him a networking session. But thank you, Romano, and thank you, MLK. Yeah, and look at the Wi-Fi. Thank you. Okay, now we're going to data enablement. Sorry, just a second. So we're going to the data and enablement section. Before I hand over to Frank, just some information what we're seeing in the digital sandbox and what people are asking for. So these are the sort of data sets that we get, I guess, constant queries on. You can see this is a bit of a word cloud. So banking transactions data is quite big in that request. Also got credit loan application data, some consumer profiling data, and then you start seeing fraud is quite big as well. So it's getting a bit of an indication about sort of data sets that we see people requesting. Also, we've got some of this data in the sandbox, some of it's synthetic, some of it's public. This is more of a general call out to anybody in the audience. If you have data that you would love to give to me for free, come and speak to me in the break, and I'll see how I can get it on the digital sandbox through Naya1, who's here somewhere. Thank you. So yes, just a bit of a call out. If you do have any data and you think you can help give that to a bigger community for development, we'd love to see it in the sandbox environment. So that's my little plug. I'm now going to hand over to Frank at Abjusir Holdings. Thank you, Frank.
Thank you, Mark. Good morning, everybody. As Mark said, my name is Frank Armour from Abjusir. I'm joined today by my colleague named Chadri, who's our technical lead. So I guess in a sentence, what we're all about is helping banks and other firms protect their customers from fraud, and in particular, APP fraud. So to lend some context to that, I'd like to start by thinking about an APP fraud from two perspectives. So from the point of view of the bank that makes the payment, all they see is the cash leaving. Yeah, the customer gets hit once. But from the customer's point of view, oftentimes, and this is particularly the case for things like romance scams or police impersonation scams, that customer gets hit more than once. So what we have done is we built a solution that will allow our banks to do a couple of things to tackle that problem. So firstly, it can match customers, and it can do that cryptographically on a bank-to-bank basis. Critical point being that personal customer data never leaves secure domains. And then once that match has been created, the second thing it allows the firms to do is exchange fraud intelligence. And that can be something as simple as a flag, so I've been the victim of fraud, through to messaging, which we'll see later in the demo. So next up, I'd just like to explain how the solution works. And there's two principal components. First up is generating a cryptographic key set for the customer. So we've got one here, Jane Doe. And what we're going to do is we're going to sample from Jane's personal data. We're going to take some components there. I've highlighted in red. We're going to pass them through a hash. I'm going to do the same again with some other data. Again, that's selected components. And incidentally, this is quite stylized. The actual technical solution is a wee bit more complicated, but at least it helps the presentation flow a bit more easily. You can see there, I'm building up, and I've generated 4 hashes there, which in aggregate have captured all of the informational content of Jane's personal data. And together, we aggregate those into a key set. But the crucial thing here is that that key set is specific to Jane. So it's only those firms that have Jane as a customer that can generate the key. The next part of the solution is what we call the trusted network. So we're going to build one here with 4 banks. Here we go, 1, 2, 3, 4. We're going to add a telco just because the system is kind of equally applicable to any firm, although we're concentrating on banks here. And we're going to bring back Jane. We're going to generate the key set. So Jane, we're going to imagine, has a current account at bank 1. She's got a credit card at bank 4, savings account at bank 3. And then we generate a key set. So bank 4 generates it. So does bank 1. They exchange keys. They get a match. Similarly, bank 3, bank 1 do exactly the same thing, get a match there. And then finally, bank 4 and bank 3 do the same thing. But notice that the telco and bank 2, because they don't have Jane as a customer, can't generate the key. That's important. But what we built there is a little network, but it is specific to Jane and it's entirely secure. So we can now use that network to start sending some messages to help protect Jane. So let's imagine that Jane's been the subject of a fraud at a savings account at bank 3. So what that bank can do is they flag that fraud has taken place and in real time share that intelligence across the network with bank 1 and bank 4 so that they can put controls in place to help protect Jane. Now, I've spoken here about sharing flags, which you could use in decisioning models, but the payload we've got is very flexible. And one of the aspects of the system we're really excited about is that we can support live messaging in live fraud cases. So what we've done here is just do a quick screen grab of the system in action. I'm just going to run a video. We're just using Postman here to send the messages. And we've got a 3-bank network, A, B, and C. And what we're going to do is we're going to send a message from bank A to bank B. So first up, they're going to say this is with customer consent. That's very important. Our customer has been the subject of a police impersonation scam, and they're going to advise that to bank B. There we go. I'm going to send that. Message is gone. I'm going to switch from bank A to bank B, pick up the same customer in exactly the same way as we saw before, scroll down, and there we see the message has been safely received. So a little now about our project objectives. There were 4 in total. The first was simply to set up a 4-node network of our system to replicate the data that's in the APP fraud data set in the sandpit. That spun up in 20 seconds for the 20,000 customers. We were pretty pleased about that. We've worked hard getting the speed up. The second was simply to match the customers across the banks in that data set. And we achieved a 100% match rate, 0% false positive. That's good. Sounds good. It is, but little rider, the personal data in that data set is pretty perfect. There's no errors in it at all. So what we did was we started introducing to that data the kind of quality issues you see in the real world. So things like I don't know, addresses being presented in a different format, things being reordered. We all know the stuff. But we still managed to achieve a 98% match rate. Again, super pleased about that because the kind of variations we were introducing were way more than you get in the real world. And fourthly, to exchange data, you've seen there we're doing messages to give you a sense of scale here. We're exchanging sub 1 second for 20,000, so it's near instantaneous. But it is the 5th objective that we're most excited about because we're hoping this will involve you guys, the audience. So this is just a shout out. Basically, what we'd like to do is to get a handful of partners to work with us to role play each of the 4 banks within that network to spark ideas about how we can use it, different use cases. Don't need IT resource. All you need is a browser and a little bit of enthusiasm to combat fraud. Time commitment, pretty modest. Just work with the other users to kind of generate those ideas. And if you have appetite for that, please buttonhole me after this or contact us at Abjuser. And I think that's 8 minutes, Mark.
Thank you, Frank. I love it when we're on time. And I also love the fact that you're plugging yourself afterwards, which gives me a reminder. There is a QR code out in the mezz somewhere, I think, where you might be able to scan that, and it's another opportunity to connect and ask questions of any of the teams you see today. So with that out of the way, do we have any questions in the audience?
So who's hosting the networks? So who's hosting the networks in the background for the banks? Are they maintaining the network between themselves as a private net, or is it more of a public domain that's cryptographically encrypted?
It's hosted within the secure domains at each of the banks involved. So the idea here is that there isn't anybody playing the middleman, which you see in the classic models for data sharing that you get with the credit bureaus.
So banks are effectively just running their own nodes and talking to each other. Okay, fine.
Correct. So it's pure peer-to-peer. Yeah.
Hi, Frank. Just interested to understand a bit more about how challenging your data set was. In the real world, it's not just about formatting, but out of date and inaccurate data as well. Can the system handle that?
Yeah, we spent a lot of time on this. So it's everything from people using diminutive forms of forenames. So everyone calls me Frank. My legal name is Francis. So stuff like that. Spelling mistakes, typos, data being missing, you name it, we threw it at the system. I mean, I worked in banking for 35 years, most of it building models. And believe me, I have an innate understanding of just how poor it gets. Yeah.
Anything in the chat?
So this is a question from online. How do banks currently exchange information about customers with each other, and how does this differ?
Okay, so the classic model, as I just touched on, is the credit bureaus. So big file of customer data, send it through to something like Experian or Equifax. They match it in the clear. and then you charge you a lot of money to send data back. That's the classic model. Forgive me if there's any bureaus in the audience. And this is peer-to-peer, so there is no middleman. That's the crucial difference.
I think there is a bureau in the audience, but yeah. Sorry.
Hi there. What about the existing fraud signal sharing networks like CIFAS, Synectics, and National Hunter?
Yeah.
Do you link into those with this?
Could do, and would absolutely invite those guys those teams to take part. I suppose the critical thing for us here is that the existing networks tend to focus on either onboarding or bad actors, and there's not much around which is real time and helping the good guys. Yeah, this is about sharing intelligence directly with the banks so that they can act immediately. Because when I spoke right at the start about getting hit more than once by a fraud, that happens sometimes in the same day. So it's that live interaction that can be critical.
Pointing over here, but I might hit two people.
Okay, just a quick question. What is the scalability of the system? Like, let's say if you want to roll it out to a lot of different banks, lots of volumes going around, and perhaps third-party vendors as well, to get this sort of information sharing out there.
Yeah, so that's exactly what we're working on at the moment. We've scaled it up to a base 600,000, I think, name, and our next challenge is to spin up 4-node million network. But the speeds that we're looking at here and giving the processing resource we're applying, we have no concerns about speed and scalability.
Okay.
We've worked so hard across the last year to get us to the place we are.
Got hot mic'd off. Most important part. Thank you.
Sorry, and then.
Yeah, I was just interested in the key code that's generated. Does that have to change if Jane gets married or I have a sex change or anything like that?
It absolutely does, not for sex change because we don't capture sex, but if Jane changes her full name or changes her address, obviously the firm involved would have a customer update process, and that would patch straight through. So we would respond to that as quickly as the institutions update their data and serve it up to us. So it's all geared up to be real time.
I think we've got time for one more question.
Hi, I would like to know if the client is aware of her or his information being exchanged between banks, or do you have that kind of consent of the customer?
So what we would envisage is that if we were, for example, sharing the fact that the customer had been a victim of fraud, that intelligence would be shared with their express consent. For matching that and sharing personal data, that consent is usually already given in the terms and conditions of the product, which is why there is such extensive sharing for credit purposes.
Great, and thank you very much, Frank, or should I say Francis? Yeah, thank you, FCA Holdings. All right, we're up to demo number 4, which is, I hope you're pronouncing this right, Ikai? Ikai, great. All right, thank you.
Hi, I'm Priya Misra. I'm the founder of Ikai. We have been at it for about 6 to 8 months, started in August. I myself have been a financial consultant to retail banks, Lloyd's Banking Group and Nationwide, to name a few. And this startup has originated from the challenges that I've faced, or rather organizations are facing at the moment. We are in the compliance space, regulatory compliance. We are looking for pretty much any organization that is currently regulated by FCA, especially within the financial domain, but our product doesn't specifically, is not catered only for financial domain. It can work on healthcare, energy, or any other sector. As I think most of the audience here might have realized, the regulation is changing. It's no longer a case of providing a report every quarter, every year, and that would be it, the end of the regulation. With newer regulation, and that's what we're focusing on. We're not looking at financial crime or older regulations. is that it's more complex. They're more detailed and they're more real time. It requires a lot of effort to generate the reports, but again, a lot of effort to provide any queries that might come back from the regulator like FCA. So we are currently focusing on operational resilience. DORA is the same sort of regulation for EU, consumer duty and ESG, and any other new regulations coming in. Of course, to handle these complex regulations, we require newer tools, and to the benefit of the companies and also to regulators, there has been a generative AI sort of has come in and provided those tools, at least the tools to build something on top of it. So we're talking about generative AI and fine-tuned domain-specific models. So our product AKI has got two components to it. We call it Nimble. That's the basic architecture of our platform. And we'll talk about as to why it is innovative and how it can help banks de-risk the implementations. And complementing it is a regulatory chatbot, which I'm sure we are all aware of from ChatGPT sort of interface. Very similar interface. It doesn't require too much of a training for the colleagues to staff to get over it. Moving on to Nimble. How many of us here have heard about small language models? Can we see a raise of hands? Great. So thanks for that. We all know about OpenAI and Chat GPT 3.5, 4, and newer ones coming out, Llama and other models. These are all classified as large language models because they run into hundreds of billions of parameters, and they're great. They're great at doing generic stuff. They can generate anything from a poetry to a book or even images in some sense and interpret an image. Where we are going with our architecture is moving towards smaller models. What research has proved over last 4 months is that it's not necessarily the quantity of data that makes a model better. It's the quality of the data, and that is where we are sort of leveraging the small language models. It gives us a great benefit of modularizing the deployment, so we can actually progressively deploy. Progressively and regressively deploy or undeploy a regulation because that reduces the risk of if we were to take out just one block out of the implementation. So for example, if we would not want consumer duty, I'm not sure for what reason, we can take just that model out and the other bits will still work because we've got a core at the center which connects everything together. The other bit, as I mentioned, was the Reg Hub, and this is a natural language chatbot. It plugs into our core and Nimble, and not only gives you queries for the regulation. So I can understand when a regulation gets deployed in an organization, we are talking about the team understanding it, and there are a lot of other things going around with it, not just the compliance team. There are other people involved in it, and they all can use this interface very easily. Today we're going to talk about two regulations, touch on two regulations very quickly as to what and how we work with them. First one is operational resilience in DORA, and the second one will be consumer duty. We all know that models are just as good as the data that we feed into it. So we have used FCA data sets, and this has actually brought down our time to market quite significantly. Not only it has given us like a expressway into fine-tuning our model, but also we were able to generate a lot of synthetic data based on these data sets. So one of the product features for our operational resilience small language model within Nimble, I'm sure some of us might be aware of important business services concept within at the heart of operational resilience, and how it is, at least that's what the information that I have with some of the organization is, it is causing a lot of issues as to what that IBS is and how do we actually represent it. So we have got a tool, a module within our platform that can not only read structured data, it can read unstructured data from design documents, user manuals, which have gone through the governance processes of the organization, and it can create knowledge graphs for various streams. So as you can see, a process graph of how an IBS looks like, what applications it contains, but also a data graph that underpins that application process, infrastructure graph, and most importantly, people graph as to how people are interacting with that process. Another important component of operational resilience is scenario testing, and this is again a different kind of testing, and companies are coming around to it. Again, we use a lot of unstructured data, vulnerable data, incident data, and create severe and plausible scenarios. I think that's the language that has been there in the operational resilience text, to come up with various a spectrum of tests that would be required to prove an IBS is within the tolerance limits. I'll go through this quickly. So we've got any organization that has survived a few decades would know that we're talking about mainframe code that only one person can understand, who is kind of the god of that particular organization, because there is new skills is not coming in, and the older technology is not being kept up to date. But there is no way to move it because people who understand that code either are not there anymore or very few. So this constitutes like a key person dependency risk, which is quite evident. And our platform provides a way to not only document that code, which will help understand it. It can duplicate it, maybe in another language if you wanted to, and also update it if need be. Coming on to consumer duty, and I'll be the first one to have the gong, I think. Again, we've used the data sets from FCA, various ones. And again, synthetic individual data set was great for creating further data sets on conversations between customer and banks. And that is one of the modules that we've got to analyze how whether there is a good outcome for a customer or not. I think that is the main crux of consumer duty. And to analyze hundreds and thousands of conversations coming in via different channels is humanly impossible to do. We do a sentiment analysis not only on the conversation but an overall experience of the customer, to say that if we had like 5 complaints, how it was handled. And similarly for vulnerable customers. So vulnerability is like it is 2 phase. It can be permanent, it could be situational, and we help companies get around it. Just a quick plug here for Nimble Advisory Council. I would love if you would like to join us on this or to make our roadmap. Contact us. I'll be here all day, and I'm on the thing as well. This is our contact information. Thank you very much.
Thank you. At some stage. Thanks, Priya. Rightio. So that's the first time I've gone over the gong. So no. Do we have any questions in the audience? Yep.
That button's a bit sensitive, isn't it? In terms of operational resilience, the UK approach is much more on the resilience rather than the stopping the threat, which is like kind of more DORA. What does this look like in practice for either an FSI or one of the soon to be designated critical third parties in terms of things like sector-wide playbooks and the like?
Yeah, so definitely, I mean, operational resilience is a broad regulation, and obviously one part of it is like third-party risk management, and also outside of the company that is doing operational resilience. We are partnering with people who are doing third-party risk management. We're providing our tools to them. So I think unstructured data to knowledge graph is a tool in itself, and it can be applied to various use cases. But we are building those tools, and we are using a use case to sort of prove it. So I'm not sure if I answered your question or not.
Yeah, it was more like kind of what does it look like in practice? So I'm kind of looking to procure your product. Kind of how does that help me? Kind of what's the application?
Yeah, so our product is a private SaaS based deployment. It'll come in as a package. Depending on how many regulations you would like to deploy. So for example, there'll be a core and an operational resilience in your case, and it'll reside within the secure domain of that organization. No data we don't use any data of the company to train our data sets or anything. From then on, it becomes a very simple sort of interface. The Reg Hub is our window into your window into the model. And there are no complicated sort of buttons, menus, or anything. I mean, it's just like you're conversing with a co-worker is the concept here. And that does not mean that it is light on how it generates outputs. It can generate graphs, charts, reports, even up to a level of how would an IBS vulnerability or tolerance looks like. Thank you.
The consumer duty module.
Just bring it forward a little bit.
Apologies, I've got a cold. Hopefully you can hear me. The consumer duty module seems a bit linear based on initial observations, in that it seems to focus on linear MI, such as customer sentiment and complaints. My question is, does the platform have the capability for firms to use it to define good outcomes in a more expansive way for monitoring against the awful outcomes under the duty?
Yeah, thank you. Good question again. So this was sentiment analysis, I think, the base of deciding on a good outcome. But as I mentioned, we look at as to what that customer has gone through in the previous interactions with the company. So it could be complaints, it could be opening new products, it could be trying to just query something technically, because it is, I think the outcome at a certain point in time is driven by what that customer has experienced in the past. I mean, I myself would be guilty of, starting off at a different level or tone with a company if I've not had, good experience with them. So it actually looks at the holistic picture of a customer. But the good thing is that it can classify them really quickly, which is, it is flagging out processes which are causing these problems. And I can give you a example, but one of the companies requires 4 security questions to be answered, but I cannot provide them for certain reasons, and I think that process is broken somewhere, and the company would only realize it if it has been flagged. Thank
you. I think we've got a question from the live stream.
Yep. So this is a question from online. Do small language models also mean less parameters than large language models, or is it just less and more specific training data?
Yeah, good question again. So it is definitely less parameters. So we're talking about a number of billions, not hundreds of billions of parameters here. So to give you a size of scale, we're talking about our core is about 13 billion parameters. Our individual modules will do 7 billion parameters.
Great. I'm going to take some time back because you went over time. Thank you very much, Priya, and thank you very much to Ikai. Okay, this is the final demo for this session. I'm going to hand over to XCharter.
Hi everyone, it's really great to be here today, and we're very excited to introduce ourselves and our company XCharter. I'm Venetia, this is Louis. We are the co-founders of XCharter, which is a company that is aiming to unlock the value in data. Louis and I met as strategy consultants at Bain & Company in the technology practice. From there, my journey to XCharter was via a master's in computer science at Imperial, where I focused my research in computer vision, which is the technological backbone of XCharter. But for both of us, really, our experience at Bain in the world of data, and particularly financial data in private equity diligence and that sort of thing, was fundamental to why we decided to start this company, because we confronted daily the challenge of unusable data. So our mission, what we're really driven by, is the belief that any data in any document and any format should be accessible and understandable as soon as you find it or it hits your inbox. So we estimate that investors, analysts, and consultants lose something like 400 million hours a year to extracting and interpreting the data in documents. And more than that, we believe that there's huge potential value to be derived from documents that aren't currently machine readable. So if you just think about the thousands of PDF documents that are probably lurking somewhere on your hard drive, full of graphs and charts of really valuable data that you can't really use in a meaningful way. So our goal at XCharter is to enable enterprises to cut out the time spent interpreting data in documents and to enable the generation of new insights from previously unusable data. So I'll talk a bit about where we are now on our starting point. So we launched the company at the end of 2022. And since then, we've launched the world's first product to extract data from charts at scale. We've built a proprietary deep learning model and computer vision solution that converts chart images into numerical usable data. And this helps to solve a failure point of even the most sophisticated large language models. Why did we start with charts? Well, really, there are three key reasons for it. Firstly, precise extraction is a highly complex technical problem for which there hasn't previously been an adequate solution. Secondly, the kinds of customers that we deal with, which are financial institutions, investors, consulting firms, tend to present a vast amount of their most important information in the format of charts. And thirdly, it's just a problem that we know really well and have been burnt by ourselves. So in our time at Bain, we'd used tons of chart-heavy documents. Often we didn't have the source data behind those, whether that was management reports, equity reports, you name it, information memoranda, et cetera, et cetera. And I think every analyst knows the pain of the late night realization that the data that you really need is stuck in a chart. And the only way to get it is to resort to printing it out, getting out a ruler and starting doing some measuring. So that's why we've developed our solution, which is now live and being used by enterprises. And we're continuing to refine and extend its functionality using data sets provided by the FCA Sandbox.
All right, hello everyone. So let's talk about how Xstrata is used today. We really enable two main use cases. The first is to increase analyst productivity. With Xstrata, no analyst has to deal with locked data in documents. They can have all the charts, all the tables, for example, from an IPO prospectus, in a usable Excel format in seconds. And this is enabled by our browser-based SaaS tool, which I'll show you in a second. The second is a systematic scale use case. Through our API, we can extract from large document sets, for example, a company's historic data or every external document shared with a deal team. This data is then typically fed into a database, which in turn is surfaced to an LLM, and we thus vastly improve the accuracy of LLM output on visual data. As an example of the kind of benefits we drive, we see our customers in the due diligence space saving about a day per analyst per deal through these use cases. I'll now show you a demo of the web-based SaaS platform. I'll run a 2-page PDF through the product, and I'll pull that up now. So these pages, as well as a lot more data we've used to train and test our technology, was sourced through the sandbox provided by Insig AI. The document has 2 charts in it. The first page contains a 2-series line chart from a New Farm annual report. And the second page contains a cluster bar chart from a Renault ESG report. So this has 3 series and no labeled values. Heading back to our product, I'll hit Use Xstrata. I'll upload the document we just saw, and then I'll extract the data. So what's happening now? Our deep learning technology is detecting the charts and tables, as well as relevant metadata, so titles, sources, units, series names, and our computer vision algorithms are performing the numerical extraction using a variety of techniques, such as object detection and color segmentation. So the extraction has finished. Let's have a quick look at the results. Our UI pairs the original page on the left-hand side with the extracted data, which we replot on the right-hand side. Let's take a look at that now. So essentially, an analyst can easily compare across to check the accuracy of the extracted data. And scrolling down, you see the data table with the numbers in the chart. And here are the results for the second page, the cluster bar chart. The original page on the left. On the right, we have the extracted data. And then scrolling down, we see the data table. The final step then is to hit download data. This returns a single Excel file. It contains a summary sheet with each of the charts or tables we've extracted from the document listed. And then there is a sheet for each of the charts. So the first sheet is the new farm report. Scrolling down, we see all the data points in this line chart. And then the second sheet is the Renault report. So here's the cluster bar. The data is then ready for the analyst to use, so to interrogate or plug into a model. We've shown you the SAS tool here, but the process and the results are very much the same for the API, just at scale or embedded in the platform. So how are we using the Sandbox? I'll illustrate that with a quick case study. So we've been collaborating with INSIG AI, an ESG data platform, consultancy, and data provider. It started with INSIG providing us with large data sets to test and train our technology. And now INSIG are actually planning on using XData in their own platform. So they'll use our API to augment their own machine learning models. And they'll also embed us in their SaaS front end to help their users interact with documents. So look, thank you very much to the FCA for the opportunity to be part of the Sandbox. It's been fantastic to get introductions to mentors, access to data, and unlock a network. And thank you to you all for being here today.
Is that coincidental? Did the time actually, was that the exact, that was well timed?
I think they gave us a bit.
Oh, okay, good, all right.
I'd like to say it was good planning. I think they gave us
All right, well done. Just full disclosure, I used to be a management accountant and I love spreadsheets. Right, any questions for XData?
So how does the system deal with the McKinsey-like thing of basically not putting a scale on there and not necessarily sticking to a linear scale? How does it kind of use the information around it to understand how they've come to it and what scale it should be?
Yeah, it's a great question. So it really depends on what you've got. So if there's absolutely nothing, the best it's going to be able to do is index it, which is what it will do. To the extent there are any values given, it will use those, but it's also always measuring at a pixel level. So it's sort of taking all of the information it's got. And one of the things that we're currently building in is integrating in LLM functionality that gives you wider context as well. And it it uses as much information as it can find, basically.
We've got one question from the live stream.
Yeah, so this is a question from online. Are there restrictions on what type of graphs or charts can be extracted from? For example, if I had a report with lots of specialist plots or something with heavy novel graphic design, would it be able to extract from that?
Yeah, also a great question. I mean, it's partly where we are in the roadmap. So like I said, we're a relatively young company. We focused primarily so far on the very frequently used business type charts. So what is currently live in production are all types of bar charts, segmented, cluster, unsegmented, vertical, horizontal, line charts, pie charts. And then we also have the functionality for cascade, so waterfall charts and area charts and scatter charts. Those aren't yet live, but will be. And then there's obviously a very long tail of things that you may or may not describe as charts, which kind of get increasingly into the infographics world. And for those, we leverage, so all of that stuff is done with proprietary technology. For stuff which is less chart-based and more infographics-based, we've started to integrate, like I said, LLM technology, which can do more useful things. So that's
just a question, like all these systems always are a bit like of a black box. Is it open what you guys do in the back end? So for instance, if I make a decision based on your export from a graph to an Excel, which I use then later on to make a decision, is it traceable to see how you extract it? If there's a requirement for it, like for say a regulator comes by and said, you made the decision based on this data, which comes from this extraction, which we use your software for. Can we trace it back to how you actually did it as a client?
As a client, not currently, but what, like Louis said, and one of the things that we considered to solve that problem is the fact that you can always see what the original source data was as well. So essentially, when this is at its most useful, it does what the human eye would do, but it does it in a fraction of the time and more accurately.
And it's worth saying we extract kind of relevant metadata, so kind of the position of the chart on the page, the title, the source. So it's not just the numbers, it's the numbers in its context on the original page. We don't explicitly, link to a specific report, but I think it's a great point and something we could think about doing.
I've got one here and then I've got one more in the chat, and I think that will be it. Sorry.
Thank you very much. Just on accuracy again, do you do sort of a quality assurance or quality check, since there'll be reliance placed on that?
Yeah, a great question as well. So we're currently, so it's obviously being tested a ton by us, both internally and with customers. We're in the process of building in something which essentially does a deep learning quality assurance check to check visual similarity. And that is the way of then being able to exclude any results that you have insufficiently high confidence in.
Great. And final question.
Yep. So again, this question's from online. With Global Accessibility Awareness Day next month, what distinct and proactive measures have you taken to create a product that is accessibly conscious?
That's a really good question. I mean, I think we consider one of the real strengths of the product to be that it is inherently accessible. So for instance, we have had a lot of input from someone who's very visually impaired. And for him, one of his real challenges in life is that he gets a ton of data in charts, and there is nothing that will be able to do anything useful with that. But he can do stuff useful. He has the technology to be able to do useful things with numbers. And so this is a step in that. So we really see this as a very important part in the accessibility story.
Great, fantastic. All right, that's everything we've got from Xcharter. We have quite a lot in fraud because that's kind of been a flagship, I guess, data set that we have, the authorized push payment fraud data set, which we've had Smart Data Foundry working with us on, and City of London Corporation. Forgive me, I haven't looked at these slides yet, so I'm going to wing this a little bit. Fine. So this is what we've got in terms of authorized push payment fraud. This is a synthetic data set we put onto the digital sandbox. This is giving you a bit of an idea of, I guess, how it works. It's not quite a data schema, but it's giving you an idea about, okay, what's the different types of data sets that are in there? How do they all kind of work together? So you have like these banking transactional data sets, which I believe is about exactly four synthetic data banks. We also have it connecting with this telco data. So this is kind of like, how do you see or test system where you don't necessarily have all of the data points. So this, I believe it's probably one of the first times you've been able to connect a different sector where you have like referential integrity between the banking data sets and the telco data. And then you have these fraud typologies that work across those data sets. We have the individual transactional data, and you've got corporate transactional data on those banking data sets. So there is kind of both in that system. On the telco side, you've got the individual telco data and the corporate telco data. So all of that creates an ecosystem of data where you have fraud typologies. We've been working on the data set and how do we improve it. So we have had people using it. They've been playing with it. We've brought them in for some workshops. We've done surveys with them to think about how does it get better over time. Since we've launched the data set, we've got 24,000 data calls on that data set. And we've had about 41 organizations provide feedback. And we're, I think, on our third round of improvements. So there's 4 iterations of the data set for this year. This is iteration number 3, I believe. I'm trying to get David's attention somewhere. So, yep, confirmed. All right, brilliant. And we have the opportunity to ask people to come in, have a look, and see what improvements can be made. There were some comments today about people who've already used it. The data is very clean, so that matching exercise, I can't remember which presentation it was now, but the matching exercise of where the data is so clean, it makes it a bit easier to match. I think that's one of the improvements we've talked about. So that's what when we say we're improving it and we're trying to iterate it, that's what we mean. So how do we make it more useful for people who are going to actually use it? But it is purely synthetic. There is no risk of anybody being identified in it because we use something called agent-based modeling. So that's the plug on app fraud. So now I'm going to let the people who've been using the data talk about it. So can I bring FeedZai up onto the stage? FeedZai? Sorry, who? What am I missing? Oh, virtual. Sorry, it's virtual. Of course. So there's nobody here in the room. It's all kind of come in from Singapore. Now, when I press this button, magically there will be a demo. And then through the magic of the internet, we're going to try and have that person answer any questions that we're going to have in the room. So sorry for the confusion. This is now going to work.
Hello, I'm Robert Harris, and I'm joined today by my colleague from FeedZai Research, Hugo Ferreira. FeedZai has been providing AI-first fraud and fin crime prevention technology to banks for over 12 years. We welcome the opportunity to be part of this sandbox, as we know that the only way to defeat fraudsters is greater collaboration and sharing of ideas. It's the same reason why we are a foundation partner of GASA, the Global Anti-Scam Alliance. As part of this sandbox, we wanted to examine ideas on how to speed up the shift from simply detecting APP fraud to preventing it using multidimensional techniques and data. So here's the agenda for the next 8 minutes or so. We'll quickly highlight the problem and then move on to cover the role of tech, but also touch on the benefits to consumers, who are obviously critical players in the advance from detection to prevention. So here was the problem presented in the sandbox, 5 APP typologies. And we know that scams and APP fraud are a rising problem. We also know that there are different definitions of a scam globally. The data here focused on APP fraud of 2 main types: impersonation, where someone claims to be who they're not, and misrepresentation, where it's the object of the scam that's false rather than the person. In the sandbox data, we found a lot more cases of impersonation than purchase typologies. In reality, in the UK, there are more than 5 times as many purchase scams as impersonation, although the average value is a lot less, more than 10 times less, according to the latest UK Finance report. APP losses in the UK for many types of scam have been declining, with a trend of shifting towards higher volume, lower value scams, such as purchase. All the APP types in the sandbox are generally single events. Other scam types that happen over multiple events in a protracted time period, such as romance or investment, present different detection challenges, but these were not included in the sandbox data. So looking at the sandbox data, we first observed a good distribution of transactions over an extended period of time. We were also interested to see the top fraudster activity by agent ID, but we did not analyze this too much. And also the number of successful scam attempts is understandable for a sandbox, but it's worth calling out that the amount of successful attempts was far higher than the reality. So looking at the product then, FeedZai is a SaaS fraud prevention platform for banks. Fraud prevention is all about making risk decisions with the highest possible precision. Working with banks in the UK and in other countries, we recognise that this can be best achieved by combining as much data as possible. In order to identify APP attacks more precisely, it's not just the payment information, but also account activity and customer behaviour on their devices, as well as the cross-industry data we saw in the sandbox that helps deliver a better result for banks and consumers. Telco data can be helpful, assuming that the banks and telcos can share the intelligence effectively. The sandbox uses synthetic citizen ID to connect the two, and we know that reality is a little bit trickier than this. On the payment data itself, only outbound payments were included. However, since we have synthetic data from multiple fictitious banks, we could treat outbound payments from Bank A to Bank B as an inbound payment from B to A. Inbound payments are a strong focus for our UK customers as we prepare for the PSR shared liability split in October. We found the best results can be achieved by a combination of rules and specific scam machine learning models. It's also important to look at individual behavior over extended time periods. And it's worth calling out, we did not look at the Sandbox business data. The innovation we've introduced is not only analyzing, but also capturing all this data from all these sources on a single platform. Looking at call data, we know that phone calls can be a strong indication of fraud. If it's an incoming call about 15 minutes in length, as a victim is setting up a beneficiary or making a payment, has a 25% chance of being a scam. As a result, we've recently seen several countries implementing a time delay or cooling off period between setting up a payee and allowing a payment to be made. However, there are some questions that remain. Is it feasible to check every payment against the telco records? What about calls on WhatsApp? And interestingly, we also saw how some scam center operations changed their tactics. Last year, for example, victims were being sent into branches to make the payments. Or on other occasions, victims were prepped on a first call, which was then hung up, and a second caller called back in order to instruct the payment. Hence, it's worth bearing in mind that any rules, models, and the underlying data needs to be easily adaptable. So what's the benefits and impact to consumers? We all know consumers themselves are the first line of defense. More precise risk decisions in the bank enables a shift from generic to single smarter interventions. A study by FINRA, for example, showed that even simple messages can reduce consumer susceptibility to fraud by 40%. However, the impact is rapidly lost with too much repetition. So frequently changing warning messages and being more selective in their use, and ideally making them contextualized, is the greatest benefit we can offer consumers in order to foster trust and make them feel more secure in their banking relationships. And that's why more data means more precision and better protected customers. So what are future plans for FeedZai? Well, in a word, it's collaboration. We're looking at APP network fraud detection, working with Form 3 as an extension to their account-to-account payments platform, using models built on confirmed fraud labels that uses collaborative intelligence that uniquely understands the behavior of both the sender and the recipient. We're also talking to our customers about telco data. And one of the first things we have to come there is how we can provide that through a single aggregator. Also focus very heavily on inbound payments in order to support the PSR APP reimbursement regulation coming up. But by the way, we'll also support mule detection. We're also working with a workshop at the GASA Summit in June on cross-industry collaboration on how banks can work together with other sectors. Great number of attendees. You can find out more at gasa.org or apply to FeedZai for more information. Thanks very much.
You can clap. All right, so this has worked great. So we can have questions from the audience or from the live stream. We have Robert and Hugo. Can you hear us?
I can hear you. Not sure about Hugo.
Okay, well, we've got a picture of Robert and Hugo. There, we've just got Robert. All right, great. So any questions? Yep.
Hi, can you tell me what were you trying to achieve from the Sandbox program then? Because you're obviously, your business is slightly more mature than others. And so what was unique about either the data or what were you coming out of it? Where were you trying to go with this? Because it comes across as a fully formed product already, which you're primarily providing to banks. So maybe just cover a little bit about the data and where you go next with it.
Yeah, Josh, thanks very much. First of all, let me apologise for coming to you virtually and not in person. But my wife is Singaporean, and this is an important time in Hari Raya, so that's why I'm in Singapore and not with you in London today. So to answer the question, and I think as we finished on in the presentation, it's about collaboration, understanding the data. The more data we can use together and bring it together, the more chance we have of identifying those fraud scenarios and those fraud typologies. So yes, we looked at the data. There were some interesting concepts in there, right? So that's what we were focused on primarily, associating the telco data with the bank account data. It's a bit of a no-brainer, really. Obviously, the way that gets administered in the sandbox is a little bit obviously simplified and streamlined, using a citizen ID to join the two. But actually clearly shows that demonstrating bringing that data together is a benefit. The other aspects which we found that wasn't quite developed enough was around like the corporate aspect for the purchase scams, and the reason why we didn't dig too heavily into that was because that we're still a little bit away from getting that data into the bank's decisioning platform. How you can get that corporate data in, but there are some useful signals there. The latest data for the sandbox, I think was mentioned, it's come out just this week. So we're gonna look at that. So you're correct. Yes, we do have a fully formed product, but there's always opportunities to bring in more data and make those more precise risk decisions. So we want to be part of this, right? We're not going to solve it. Same reason we're part of GASA. No one organisation is going to solve this on their own. So just collaborating with others is a great start in that journey.
Great, thanks, Robert. And it's also useful to get that feedback from the data as well, so that helps us improve it. So thanks for that feedback. I know that we're taking notes. Are there any other questions in the audience, or do we have any in the live stream? Yep.
Hello. Yeah, hello. My question is around how is your product different from the products out there today, and this from the point of collaboration? How does it differentiate itself today? Thank you.
Okay, I can touch on that very briefly. I don't want to necessarily go into any sort of sales pitch here. I think where we see our products as differentiated, why we built it out like this, is because we have a single platform, as I mentioned, that we've sort of further enhanced in the sandbox to be a single platform that not only analyzes the data but collects that data as well. We can collect data from different sources, and I think the ability as well to transform those models rapidly and deploy them into production quickly is another great differentiator for us. So there are a lot of solutions out there, but we think we have a different approach to this.
Okay. Do we have any other questions in the audience? Denise, let's see you.
Hi. Have you, sorry, and I'm sorry if I missed this, but have you set up a kind of a standalone fraud monitoring process, or is this integrated into your kind of anti-money laundering transaction monitoring kind of solutions that are being offered?
So it's a single platform. It's a single platform that covers the full customer life cycle, right from day one, day zero, from onboarding the customer right through to the anti-money laundering aspect. So it's a single platform, but there are, yes, configured on that, there are solutions that can be modularized and switched on and off as needed. Does that answer the question?
Kind of. She made a kind of.
I waved my hand. Yes. Thanks,
but I guess we can collect that later. Maybe you can answer in a bit more detail. Are there any other questions in the room? Anything in the live chat? No. Okay, and I have the bell. So thank you, Rob, and thank you for joining us from Singapore. And thank you to FeedZai. All right, now we're back into real humans. Resistant AI, maybe not. I don't know. Ooh. So over to you.
Yeah, thank you. I'm Kathy. I'm the product manager at Resistant AI, and I'm joined by Sam, our machine learning researcher. And Resistant AI, who are we? We are a machine learning company, and we support financial services firms to strengthen their controls against fraud and financial crime. And we have machine learning at our core. We take an ensemble approach to detection, meaning we leverage various different machine learning techniques and approaches designed to detect adversarial actors. So identify fraudulent actors and other criminal actors before they have the opportunity to scale their attacks. And we were really, really excited to get access to the Permanent Digital Sandbox and the APP synthetic fraud data, as it provided us a really rich and powerful data set that, quite frankly, we would not have the opportunity to have in real life. So it was a very exciting thing for us. And what we wanted to do with the synthetic data is see if it can help us to overcome some core challenges in fraud detection. FeedSci just did a really good job at kind of outlining some of the current challenges with fraud detection, but I'll do a quick summary to frame the discussion. So you'll all be very familiar with these. Many organizations, of course, limited by the frauds that have been reported to them, so what they know as an institution. Typical fraud detection approaches rely on institutions' data, so transactional and customer information alone, so what we see as traditional data sources. And of course, there's continuing data privacy concerns that limits us from freely sharing information about frauds and fraudulent actors. So we wanted to really explore with the APP fraud data set, what does it really mean to share data, and how much data is necessary to have a true impact on fraud detection. So we sought to answer the following questions. What is the detection uplift when we look to capture information on fraud from a range of financial institutions, so the 4 banks within the synthetic data set? What is the detection uplift when we look to leverage non-traditional data sources, like the telco data that was made available to us? And again, what level of data is actually required to be valuable? What is the minimum data set that provides maximum uplift in the detection? And I'm going to hand over to Sam, who will be able to present our answers to those questions. Over to you.
Sure, thank you. Yeah, so hi everyone. So basically what I want to talk about in this presentation is the different schemes under which data could be shared, the different kinds of data which could be shared, and maybe most importantly, like the effect on the performance of whatever system is being used at the ultimate goal, which is of course preventing APP fraud. Cool. So now to answer these questions, we need some data to experiment with, and the FCA has graciously provided us with just that. More specifically, they created a synthetic data set that you kind of heard about already. They simulated 4 banks, 2 telecommunications companies, and kind of naturally, if our goal is to understand and to prevent APP fraud, there are numerous fraudsters in this data set. They operate using different typologies, and this is all unredacted, as this data set is entirely simulated, and therefore there's not a risk of any kind of leak. Cool. So we took this data set and try to imagine different ways how the data could be shared between institutions, right? In order to kind of make our job a little harder and to make the baseline performance a bit more representative of what you might see in the wild, we sort of limited ourselves to certain features. We noised up the data set a little bit, and if anyone's interested in the details, I'm of course available after the presentation. In any case, what I want you to focus on is kind of the delta between the baseline and the various schemes that I'm going to be talking about. Cool. So what you're seeing right now is the baseline. There's Bank A, there's Bank B. A is deciding whether to allow or hold a particular transaction, which is going through one of their clients to a potential fraudster, right? Nothing too exciting to see here. Bank A builds a model which utilizes their previous experience, but it is evident in the precision recall curve that you see on the right, left, that they're not doing a terrific job at it, right? Cool. Moving on. What if we are in a situation that the financial institution would kind of share information about their previous reported cases, right? Let's say that the information about past cases would be shared with a bank before they needed to answer or like to make a decision regarding this particular transaction. They could use this information in one of their models, and it's evident in the applet that we see. This does in fact help, right? What's crucial here, and I'm leaving out and sort of obfuscating a bit, is that when Bank A, it's like when does Bank A gets the information from Bank B or whatever other bank there's in this system, right? Is it a week? Is it 2 weeks? Is it after the fraud has been reported? Is it after the fraud has been investigated? That's all like open questions, and of course like we have to model this somehow. Once again, if anyone's interested, let me know. Cool. Now, if we take this like a step further, we can imagine even more sharing, right? Basically, what we imagine here is that Bank B obviously knows much more about the fraudster as Bank A, right, or the potential fraudster, right? So if we imagine a scenario where Bank B would have their own internal system which would assess the riskiness of this client and would share this information with Bank E together with the information that Bank A has regarding this particular transaction, they can make a much better decision on whether to block or to allow this particular transaction. Cool. Once again, curve is higher. That's cool. If we move it if we kind of take it a step further, we can imagine involving like one of the institutions that I talked about, which is part of the data set, which are of course the telecommunications companies, right? And we can imagine a similar process, right? The telecommunications companies would receive information about the actual fraud cases that happened at these various banks. They would build up their own system, which would judge if a particular client of theirs is a potential fraudster, and when asked, would inform. In this case, this is Bank B, which could incorporate this information either in their own risk assessment score, or they could send it to Bank A as is, which could do the same, right? Decide based on their risk appetite. Cool. The very last thing, and I don't have much time, so I'm going to be quick here. The last thing that I want to talk about is a bit more complex. Previously, I described that Bank B shares some kind of like risk assessment that of the potential fraudster. But like what I want to stress is that Bank B has information that is much more powerful when combined with information that Bank A has, right? So now B would share this information. Bank B would share this information in some suitable feature representation, and of course we would. I mean, there's a myriad of ways that this could be done, but we can of course understand the criteria which would guide these sort of representations, right? This would of course be being privacy preserving. You can imagine criteria being commercially non-informative or like non-informative respect to some commercial interest of Bank B, right? So in the interest of time, I'm going to end it there. If anyone's interested, so catch me.
That's a red card. So get off stage, no more questions. No, this is fine. So I was going to suggest maybe we'll take a bit of the Q&A time back. So thank you very much. Do we have any questions in the audience? Come on, there we go.
Hi there. Just asking about if Bank A and Bank B have different risk appetites, are you effectively doing kind of risk arbitrage across the two? So risk Bank A, in order to block the transaction that Bank B might have blocked, they need to have a higher risk tolerance than Bank B. So how do you view that?
Well, I would say that of course, we are modeling this from the perspective of bank A only, right? We are not considering in this analysis, we're not considering the fact that bank B has the opportunity to block this transaction as well, right? So we are kind of giving the agency to bank BA only, where they only receive the whatever additional information it is, right? So you're right. We're kind of like limiting ourselves to one perspective of this analysis in order to like highlight the fact that these sort of information is like useful in general. Does that answer your question?
Yes.
Okay.
Cool. So you need to, if you might not be here this morning, you need to press the button. It goes red, and then you have to talk to Mike. Great.
Okay, thank you. I think you highlighted really well how the different scores are how you're getting better performance with additional data being added. So I was curious on your views as to what additional data out there you wish you had access to in order to produce an even better score.
Sure. I guess we already touched on this in the previous presentation, right? Basically, any form of information, or the messaging between the potential fraudster and the potential victim would, of course, be like incredibly useful, right? Whether this is like calls for some from between the fraudster and the victim using some other communication method other than the actual calls or text messages, right? This could be like social networks, this could be like device level data. These are the golden grail, right? I assume that, and the previous presenters told us that like this is where most of the progress actually happened, right? So I would say that, yeah, that would be my advice.
And I think more generally from the sandbox standpoint, because there's improvements all of the time, we would love to see data from an in-bank forward perspective. So to be able to model it from a bank B's perspective. So that's something I know the team are working on. We're really excited about developing based on.
Great. So I'm just going to go to the live stream so they don't miss out.
The question from online is, how are telco risks scored?
Oh yeah, so what I've seen here, and I maybe haven't clarified fully, is that the telecommunications companies receive information about the frauds from the actual bank, right? So they receive information that one of their clients was participated or had been a victim of a particular fraud. So these labels can then be leveraged, to build up their own models, which then can be shared, like proposed shared with the actual bank. Does that answer whoever's question?
Well, I'm sure they'll tell us online. Okay, I'm going to have this last question. Sorry.
So just out of interest, do you actually use like the CIFAS data? Because you were talking about like banks sharing information about known frauds, and obviously CIFAS is a bank sharing database of known frauds. Is that integrated in your system, the information there?
Yeah, got it.
Yeah, in general, yes, of course, this is all modeled based on the synthetic data that we have access to from the sandbox, but absolutely leveraging all data available and through our clients for our overall fraud detection. Absolutely.
Oh, there we go. There's another little bell. Thank you very much, Resistant AI. And if you've got any further questions, please feel free to catch them in the next break or the QR code scanning mechanism that's happening out there as well. Next. Oh, wow, you had a lot to go, didn't you? Okay. Maybe you can do another demo session in front of your own private audience next time. So next up, we have demo number 8 in fraud detection. We have Fintelligence. Is it Fintelligence? Yeah, okay, beautiful. All right, thank you.
Hello, everyone. We are Fintelligence. My name is Abhay. My colleague Kamal is here with us. We are here today to talk about the world of APP fraud and solving that through augmented AI teams. I have 2 stories to tell you. One is about the APP fraud. We understand that this is costing the industry hundreds of millions annually, but the other story is about an augmented AI team and that approach to solving this problem. Again, these numbers are well known. First half of 2023, 580 million reported stolen, 230 million reported lost. This year, we have some action, additional action from the regulator with the mandatory liability scheme, hopefully kicking off in October. The other story about a hyper-augmented team. Hyper is an agent-based team augmentation technology that can do the grunt work in building financial services grade products, production-grade solutions. Hyper can create APIs, partition data sets, synthesize data. It can train and fine-tune models and perform a lot of the foundational work in building robust solutions. This helps us accelerate our solution delivery, and in this case, against financial crime. The battleground, you must have heard about this already. Millions of records for banks, about 20,000 individuals in this data set. So this rich data set allows us to apply advanced and sometimes opaque AI techniques, particularly pre-trained large language models, to create practical, operable, useful solutions. So the team was given a simple mission, develop a solution very quickly to use your solution for real-time payments and transfers. Make sure that it is applied, which is practical, usable, must have explainability about it, evidence-based. So we did this work in the sandbox using this technique. We tried multiple payment attributes, multiple large language models, and we're able to identify, train, fine-tune a model with 3 billion parameters. That gave us almost 4 nines of accuracy on the data in that. So we were able to decipher the mystery that was in that data set. Provided it was able to process transactions in near real time, 100 to 300 millisecond response times. But our work just isn't about accuracy. It's about also making it useful, practical. So we developed APIs that simplify access to the solution so that easy to use and integrate into your existing ecosystems. The emphasis we also have is on the explainability of these black box techniques. So using advanced semantic and vector search techniques, providing a crucial layer of transparency. So making these algorithms more accessible and understandable. This is the sandbox UI for the Jupyter UI that many of you seen. So one of these scenarios is the advanced fee delivery customs scam. We know that the models perform well. So this one's being classified using an API format to say, yes, this is a fraud, true, positive. But that's not it. The models or the technique also allows us to identify, okay, well, the merchant name and the narrative were the key risk factors in coming to that decision. Again, mind you, we did not tell the technology that these are the factors that you must think about. That was able to experiment with them and come up with that and provide that as part of the context. Additional information about similar transactions, which further strengthen the story that this is a fraud, also being able to help investigative analysis using that. By bringing this all together, it makes for a more compelling case for the end user to deploy it. An impersonation, a purchase scam, what we saw in this case, specifically classified as a scam because of a key factor, which was the transaction category, which was transfer. Apparently, this organization doesn't accept this transaction category. Another payment with a different category, like shopping or clothing, perfectly fine. The model is able to say it's not really. So the point I'm trying to make is that with the models or the techniques are able to look at the nuanced context, which sometimes is changing from merchant to merchant to merchant. It's able to build that in and make nuanced predictions based on that. An impersonation scam, again, a telltale sign of a zero bank balance being introduced. A red flag, but not always decisive. Again, we have a number of these insights such that you can redact a large amount of payment information and still get comparable results, which means that the concerns about data privacy can be alleviated, concerns about fairness, bias can be alleviated if you can just remove those properties and still have the models perform well on that data set. Okay, so in summary, let me see. Okay, well, we're able to predict this data. We're able to analyze transaction data, identify broader patterns, put them into action defensively. Emptying a bank account, you'd be surprised at how many times people have said to me, that sounds like a no-brainer in hindsight. Unusual transaction categories, sizes, merchant-specific. These are dynamic and complex issues, but we show that these black box models can be trained continuously to develop that context and be able to respond with that. So in summary, we leverage a small agile team augmented with Hyper. which is our internal technology, to develop an API-based solution that works in a disconnected sandbox environment against a completely new data set with limited information of the topology. We wanted to go from 0 to 100. Well, it's not 0, but 10 to 100 in building this and demonstrate that this technology can work. Again, but we're not talking about silver bullets. We're not saying we have the God AI algorithm. That's not what this is about. We understand that this is about measures, countermeasures, and then some. So our focus is on speed and agility. By using this process to adapt to the dynamic landscape of the threat evolution. In the real world, transaction monitoring is relatively automated and straight through, but the rest of the cycle is slow and labored. It's primarily driven by experts and committees that look at this information, accept it, create rules out of this, and then put this in production in some kind of a safe way once you're confident that can be done so. So our challenge is not just detecting threats, but actually creating actionable insights and rules on that technology so that it can be put into production. That's not, so that's what we've done. We have other work in progress. We're looking at building evasion and collusion strategies so that we can challenge the model. Sometimes, it's the data is too simple to tell. We believe that as the regulatory landscape changes, some of these things like evasion and collusion will start to become more important. We want to stay ahead of that game. We're looking at encryption to strengthen our capabilities, data privacy capabilities. We're looking at RAG techniques to have more context to be able to explain better. But key thing that we're working on is we're looking at LLM to rule translation. So we're looking at what are these model insights? If we have learned something from this, can we put them into an executable rules technology? So if your organization is not comfortable putting an AI model live into production, well, hey, we can translate this into natural language rules for you and executable rules in a technology safer rules. So if you have existing technology that leverages that, you can simply take these rules and put them into production until you're maybe more comfortable with using AI models in production. It allows our technology to just work effectively in the background. Yes, so we're not in the front. You use the existing technology that you have, but we work in the background, give you executable recommendations, and you can approve them or give a go ahead for them very quickly. So that's us. Thank you for listening. Our goal is to be faster. We're doing some of the work, but we need you. Yes, we are looking to. We're hiring. So if you're interested, you're passionate, we'd love to have you. If you're the industry, we want to test and validate some of this.
No more hiring past the gong. That's a rule I just made up. Great, thank you. Do we have any questions in the audience? I'm just joking, by the way. You can go out and you can give your business cards and you can do your plug on hiring out there. Shirley, we've got a question from the audience, or do we have anything online?
Just interested in the point around.
Sorry, get a little bit closer to the microphone.
Sorry, I was just interested in the point around merchant name as a predictor for APP. Is it okay to just explain that a little bit more?
Sorry, on what grounds it was a good predictor?
Yeah.
Well, it turns out that in this specific case, when we did the analysis after the fact, that this merchant name actually had a behavioral pattern for previous frauds. Previous fraud transaction in this. So whether the model was able to adapt that information, whether that model information was available to the bank for last week, last month, and perhaps they hadn't actioned it, if that's how you can imagine it. Again, there's a synthetic data set, but the model was able to pick that up and say, hey, you have some records on which represent this attack pattern, and that should get classified as fraud.
Okay. I'm going to go to.
So how do you prevent these from becoming generative AI models whereby people are creating new and more interesting ways of committing fraud specifically to avoid detection?
Well, I think that we're not. I think the idea is that we have to collaborate in ways that we can be faster and better. We already can imagine that people are going to use these models to do better frauds, and that's why we talk about evasion techniques. We have to be one step ahead of the game and anticipate what kind of evasion techniques that these attackers will like to perpetrate, and how can we be prepared with solutions in advance of that, and how can we even detect potential evasion. So that's an area of future work for us.
Okay.
Sorry, very interesting work. I think one of the things I want to understand from your experience with the Sandbox is what was the biggest insight that you got from synthetic data, and how will you actually transfer this knowledge that you learned here into a real world scenarios? Basically, what's the next steps when you reach a client and you have this API?
I think I will not say insight, but what I'll say one of the key objectives for us was to apply this technique and understand the data, because we know that the synthetic data is simulated. So could we, without knowledge of how this data was created, actually understand the attack patterns that the developers of the simulation have put in place? And that's something we were able to do, and we were able to write that down into natural language. There's some variations there. For example, we saw that in some of the frauds that were being created, the category was being misunderstood, which is that an impersonation scam for bank was being confused with an impersonation scam, police. Suggesting that maybe perhaps the impersonation scam is an impersonation authority scam. Yes, who knows, right? These are just business names that we put there, but really the idea is that the intent, or trying to identify the intent, is that this is an impersonation scam, someone pretending to be an authority trying to command you to do something.
Okay. Do we have any questions online? No. Okay. There was a couple more in the audience. Sorry, to you.
So Matt, got a question, because I used to work in fraud enough time. So how do you separate between correlation and causation in terms of like the transaction name? Because I don't know how many people used to work in fraud long ago, but like cotton traders had incredibly rubbish security, and like every 3 months, cotton traders would have been broken into, and their information, transaction information, taken into account, and payments would go through. So that payment for the cotton traders thing would be flagged as fraud, but everything else related to it. So it wasn't cotton traders that were fraudulent. Like generally, cotton traders would be fraudulent, but how do you get rid of that in your data? How do you, when you're looking at an AI rather than a human who knows the news and kind of has taken in the fraud relations?
Yeah, I think that's a very good question. It's something that we struggle with as well. So our approach to this is to be able to run, significantly larger models that can help inform this decision. We see this issue. So what we're seeing is that in the real time, the models designed for real time responses, they're limited in their understanding of this. But if we look at models that are significantly larger, 30, 50 billion, 70 billion parameters, they're having better results. That is part of our work, and we're trying to see if we can use that information to train the models for real time scenarios. But work in progress. But yeah, a tough problem to solve. Yes.
Great. Thank you. We're out of time for questions, but again, if you have any, please feel free to speak to FintelligenX. Got it right this time in the next break. So thank you very much.
Thank you. Thank you.
All right. Maybe a couple more housekeeping things. For those of you who haven't been in this building before, there's a robot that controls the blinds. So it can be off-putting if you're on stage, just for anybody who's going to be presenting next. So if you hear that, that's what's happening out there. Right, so I think we're now on to NatWest. So Paul, over to you.
Hello, I'm Paul Shanks. As you can see, I'm a fraud strategy manager at NatWest, and been in the fraud and scam prevention space for around 15 years now. It's been really cool to have a play around with the data, and it's really come up with some really great ideas, and I'm really excited to be here today to share one or two of them with you. I guess the whole idea around this was to basically bring to life what we could do as a bank to harness the additional intel and data that the synthetic data set provides us, and basically see what we can do to supercharge our models, our real-time strategies, and what I eventually came up with, which was actually building some of that into our payment flows and actually presenting that in front of our customers. Much like my solution, my slides are very basic and simple. In the middle at the left there, we have the victim awkwardly. So this is actually a live case from our synthetic data set. £35,000, unfortunately, victim age 55 to 65, relatively standard that I think. Banks with Bank One, I'll come to them in a minute. And then the scam type was a bank impersonation scam. So this, again, from a big bank perspective, I guess you could say, we know quite a lot about our victim, how they interact with our services, how often they log in, who they pay, how much that is, etc. So quite comfortable with that box, to be honest with you. Where we start veering away from what is norm is when we look at the other boxes surrounding that. So let's come to the fraudster. Awkwardly, at the age of 65 to 75 is not quite what I'd class as a normal mule account, but here we are. Maybe they've been recruited or they've had their account taken over. They bank with Bank 3. Again, I'll come to them in a second. And I've obviously left bank impersonation in there again. But the fraudster history, so they've actually been received a £7,000 credit roughly 7 months prior to that as well. And hilariously, their interest seemed to be shopping sprees at a large kind of high street hardware store within the UK. And we see more of that when they receive the £35,000. Again, veering away from what's normal to us and what we see on a daily basis is the boxes at the top there. So I kind of think of each of these as entities, so we can build up behavioral profiles at each of these stages and leverage that at point of payment or also within our real-time profiling systems. So top left, for example, victim's device. We've got a decent rich history of phone calls and text messages coming in there. So again, it's kind of like a positive print on that device specifically. 42 connections as well overall. So the length of time that device has also been in use also just screams kind of genuine activity, very, very normal for that customer. Interestingly, when we then bring in the fraudster's mobile, it's a prepaid mobile device. Maybe not much of a shock to many. It only, weirdly enough, made outbound attempts. It never actually received any calls within the dataset. And interestingly, the first contact date, so when the fraudster and the victim's call or phone calls first interacted with each other, was only a couple of minutes before the scam as well. So again, instead of just calling out, we need telco data, what would that look like? Well, here's a couple of potential use cases, how we can build up, again, behavioral profiles and link them together to also notice what's genuine and what also looks a little bit more abnormal. Bank 1 and 3, really, really quickly, have a very, very nasty fraud rate. I think one of the regulators would like a discussion at least. So yeah, sending and receiving, both not a good look, if I'm being honest with you. But again, overlaying something like the PSR league tables within the synthetic data would look really cool. So at least one of them stands out and again, looks at exponentially worse than the others. So with all that in mind, what am I going to do with that data? How am I going to leverage it? And this is my next screen. Really went to town with the PowerPoint presentation on this one. So again, this is basically just bringing to life how I could then, I'm not a wordsmith, but bring to life some of those red flags. So if you imagine you're a customer, you've just initiated a payment, the app's doing all of this for you. There's lots of very clever data science in the background, but also some things are just very, very simple, as I've just shown you. And it kind of translates that into some warning messages here, and just prompts the customer to pause and basically just reassess if that payment is definitely something they would wish to make. I would say that a lot of this data will go into our real-time profiling systems as well. And it should also be, we should also equip our agents as well, should we wish to communicate with the customer and have a conversation about the payment, that we're basically presenting that to them so they can have an effective conversation with the customer, and it's tailored specifically to the activity that's taken place in the run up to it, and also what scam we think is taking place. So tipping off and whatnot aside, here's a couple of just examples of how you could potentially, I say, wordsmith that and bring that to life for the customer. I think we can all agree that it'd be better if the payment didn't take place at all at this stage, and we're obviously able to move on rather than have to obviously get involved with a potential loss case. So that the opportunity there to cancel the payment is obviously the key button. That was the main part. Just a couple of other additional synthetic or uses for synthetic data. So I feel like this is very much the beginning. It was a cool reminder that synthetic data exists, but literally, wouldn't it be amazing if we could run kind of simulated fraud attacks against our systems and our tools and our strategies to see maybe where we're weak, where we need to improve on, maybe where our models cannot quite get in front of the problem before they do become a problem. Changes in the payment landscape. So I don't know if we're looking to become more digital first. I think we all are. So what does that mean to the older generation coming in historically into our digital services, and what does that mean for our models, and also just new ways to pay as well? If we were to reduce the number of CHAPS payments, increase the number of faster payments, for example, what would that do to our detection rates? And then we've got other things around more model-y stuff here. So, you know, model governance is a massive thing for us, and if we could use synthetic data to say, push, I guess, abnormal alien-like activity through our model to test it, really make sure it's kind of robust and it's not going to break, and importantly, it's not going to hinder our genuine customer base as well. So there's a couple of ideas there in terms of making sure that we're kind of proving our models kind of robust and doing what it should do to keep our customers safe and stop impacting genuine customers as much. And that was my presentation. Big thumbs up. Thank you.
We did ring the gong, but you had about 1:40 left there, so I don't know why that was preempted. But thank you, Paul. Do we have any questions from the audience?
Sorry, you mentioned about your synthetic looking at transactional data element side of it, but obviously there's a heck of a lot of, how can I say, gift card fraud going out there, whereas making people buy gift cards and then transacting. How is your system set up to detect gift card fraud? Because obviously there's a lot of it's going through genuine websites, buying gift cards there and then.
Yeah, very different fraud feel, and very much a faster payment side of things from a UK perspective. That feels like one of the traditional examples I see when I see fraud in the US, for example, with kind of well-known retailers out there and gift cards being purchased. I guess that could be very much tailored and lifted, so that normally includes some form of fraudster interaction by a phone call or something along those lines. So again, I guess if you have the intervention points, and as a bank or a financial institution, the ability to intervene at various points, calling out to the telco, bringing that data in, and ultimately making exactly the same links as I've made up there, would very much be possible. It's just at the point of the gift card being, I guess, utilized or the code being inserted and accessed. Do we have the ability to say no at that point in time if I were one of those merchants, for example? It's up to them.
Oh, wait. I think I'll go with you again. Yes, you.
Thank you. I was curious, as you are from one of the organizations that actually has access to real data, what was the interest in using the synthetic data? Was it to find kind of fraud attacks you hadn't seen before? And then second question, the sort of very specific warning messages that you had with the really clear signals, do you have any indication that those work better than sort of more generic ones in actually changing the behavior of the victim?
Yeah, I think just to reiterate, it's really interesting to have more than just our customer standpoint and building up entity profiles of what we see. So I mean, the telco data has been spoken about for quite a few years now, and actually having something to run some experiments on and see what it looks and feels like. I don't think we're going to say it's perfect at the moment, but it gives us the ability to innovate, whether that data be 100% factually accurate or not. And it comes up with hopefully some relatively decent ideas, as we've had here today. And I think also just having both sides of the equation of the payment too is really cool. So we build behavioral profiles in terms of what our customers are doing, who they pay to, and just in general, how much money they receive, averages and COP response rates and things like that. But actually having a lot of information around how old the customer is, how old their account is, their turnover, the debit credit turnover, their available balance, all that stuff is really, really cool. What could be even better, and I think this is coming up in a future release, is more data, device-specific data as well, which will be really, really interesting to see. I forgot your second question, I'm sorry.
If I'm allowed, you presented this really specific warning message with a really clear indication of why we suspect that to be a fraud. Do you have any indication or insight as to whether they work better than the more generic ones, or is that something that you're experimenting with?
Good question. I have an answer prepared. So yeah, customers like it when it's a bit more personal. Static warning messages that have been the same for all time get completely ignored. Or they go blind to them. It's just the same message they see every time they're making a payment. So being a bit more personal, I kind of think of it in the background as almost like a Lego brick style scenario. So you'll have different bricks for different scam types, or when we have different intel, or if we can see abnormal activity on the handset or the mobile number, for example, we can build that into a building block, which will match a fraud trend or a scam trend and tailor the warning messages dynamically to the customer. Also presenting things like how bad the banks are in this scenario, just to use the phrase, like Bank 1 and Bank 3 both have a very bad fraud rate. So we could also make it a bit more personal, such as 1 in 20 customers or 1 in 300, whatever it was, have fallen victim to a scam that looked like this. So please be very vigilant. So it puts another bit of a spin and a bit more personalization on it.
Great, thank you. Probably got time for one more question. Sorry, I'll go for you.
Hi, I just wanted to ask today, do you actually work with any actual data from the telcos? And I'd also like to know what's your perspective on also getting data from the social media companies, because I think they've got, they're also a source of where the scams come from.
Yeah, and from a telco perspective, not directly, but we do have clever tools. Some of them you can Google and find out a bit more about is the customer on an active call right now, yes or no. Very, very simple and basic. And what this was hopefully looking to show is that if we had a lot more information and building up a lot more features ultimately to harness it to get a leverage within our data set, that could significantly help us. Hundreds of thousands of customers make payments on an active call in any one day, and it's not enough to just say that and block them immediately. So it's more that we need to be a bit more clever around it. Yeah, and we just heard about purchase scams. They're massive, right? High volume, low value problem. Kind of death by 1,000 cuts is what I use quite often with them. There are so many of them, and they're very hard to detect in masse. So yeah, working with the social media companies would be great. I guess you could build up a similar entity profiles based on them, ingest them into our journeys, and again present effective warning messages to our customers, but also leverage that within our fraud tools to just say no when we have high enough risk or suspicions.
Right, all right. Thank you, Paul. And if you've got any questions for Paul, please feel free to grab him in the break. Thank you. We are still in the fraud space. So I think we've got one more presentation to do in fraud, and then we're going to click over to RegTech. I am not going to get this wrong this time. This one is going to be another video. The people are coming in from San Francisco. So when I click this button, I'm sure Trident AI's video will play.
Hi, my name is Zane, and I'm the CEO of Trident. At Trident, we're building AI-powered fraud investigation tools for banks and fintechs. Today, we'll be sharing more on our real-time fraud investigation AI agents, and we've been developing this technology with support from the FCA's Digital Sandbox. So we'll share more on some of the results of experiments we've ran within and a bit more about our AI agents. Before co-founding Trident, I spent the last half a decade and most of my professional career at Monzo, where I looked after scam prevention, and then later trained as a barrister, where I also carried out some research in fraud. But ultimately, we founded Trident because we believe there's more we can and should be doing as an industry in using emerging technologies such as AI to protect customers from fraud and scams. As most people in the industry will know, the fraud rate is growing faster than it ever has before. It's a costly problem to consumers and to banks. And it's only going to get more expensive, especially as this mandatory reimbursement requirement comes into force in October. And intervention does help. If you can detect a fraud and investigate it as soon as possible, you can minimize the need to reimburse it, but then also make sure your customer is protected by stopping the scam at its source. But this is difficult to do, especially with a high false positive rate on average from most detection models, which is straining the capacity of a lot of investigation teams and creating a backlog. On top of this, when it comes to investigating scams, investigators need to be better trained. They need expertise in identifying vulnerabilities, understanding new types of scams as they come out, and then also applying complex parts of the CRM code or other relevant guidance in assessing negligence. We're solving these issues through real-time fraud investigation AI agents that are cheaper, increase capacity, and carry out these investigations and other manual processes much faster. And with AI agents carrying out the bulk of the investigation process, investigation teams significantly have increased capacity to review more fraud, minimizing the amount of reimbursements or payouts you're doing, and protecting more customers at the same time. And lastly, the two key reasons for investigation delays are internal escalations between support teams and investigators, followed by time spent carrying out a bunch of manual processes, such as reading through transcripts, browsing through legacy systems, and then writing out notes. Our AI agents take care of both, instantly being ready to communicate when a fraud is detected or reported, all the way through to carrying out all the back office processes involved in investigation. David, the CTO of Trident, will now tell you more on what we've developed within the Digital Sandbox and with support from the FCA.
Hi, I'm David, CTO of Trident, and I will now walk you through the data set we used from Digital Sandbox, how we modified it for our experiments, and what were the experiments. The dataset used was APP fraud synthetic data provided by Smart Data Foundry. This dataset has been generated by agent-based simulations of approximately 20,000 individuals over 2 years of runtime. And the dataset covers transactions, accounts, businesses, and a record of reported and successful APP fraud instances. Types of scams covered are purchase scams, advance fee, deliver and customs type, and impersonation by bank, police, or a family. We haven't used telecom operators data, but we enriched the dataset using our simulations. For each given customer and transaction history, we used large language models to create customer profile, a story, and user actions which would closely correspond to their spending patterns. So our final dataset consists of transactions, customer profiles, business profiles, customer stories, user actions, and flags for each transaction, whether it was a scam or not. Our experiment goal was to build an AI agent that investigates APP transactions that have been flagged by fraud detection systems. The AI agent should act as a fraud investigator would. The agent's goal is to determine whether the bank's customer is falling victim to a scam by asking contextual questions while having access to the transaction history, user actions, methodologies, and previous cases. From the APP dataset, we sampled 200 transactions, with 10% being true positives and 90% being false positives. We posed 2 experiment questions. First, with what accuracy can we determine if the customer is falling victim to a scam, and how many customer interactions do we need, on average, for 90% confidence? The goal for this is to minimize friction for the customer.
To give you a better example of how one experiment looked like, here's a scenario where the customer is transferring £5,000 and it's to a completely different and new bank account. So the confirmation of payee in the back end may have triggered a close match, but still something different. And this instantly triggered our APP real-time investigator, similar to how you would do with a real expert investigator. But what we can see over here is that our AI agent has instantly started asking contextual questions to the customer to try and gather as much information and investigate whether this is a scam or not. So we can see with each question, our AI agent is explaining its reasoning and gives us a score of probability that the customer is falling victim to a scam. And we can see that the first question, first of all, is trying to determine who the money is for and what the purpose is. And when learning it's for her sister's flight, the agent points out to the customer that they've transacted with a completely different account and it has the sister's name, so it starts asking about what's happening here. The agent learns that the customer was contacted through her sister's friend's number, who's supposedly on holiday, but the voice sounded like her sister. This is a common type of scam that has now been increasing in many different ways. The agent then assigns a very high likelihood of this being a scam, and eventually the customer got in touch with her sister and discovered it was a scam. We ran 200 of these simulations and found that with only 7 interactions with the customer, we can determine with a 92% accuracy whether the customer is falling victim to a scam. So this really does minimize the friction for customers and how quickly you can get to understanding whether this is actually a scam or not. And here on the graph, we can see that the scam prediction accuracy is actually growing with the number of messages from the customer support agent. As you can imagine, when you deploy this at scale, you can really capture more fraud quicker, especially with AI agents being instantly available. We're applying this technology in a few different ways. So many growing fintechs tend to use third-party help desk software such as Intercom, and we started out and have published it on the Intercom App Store. There is an AI copilot that can be accessed by customer support or a fraud investigator, who as soon as a fraud claim is detected or reported, it instantly surfaces the relevant information that they need in order to come to a decision. So this is relevant device history, a case summary, writing up a note, but then also suggesting the questions they need to ask to reach a conclusion as soon as possible. We're also building out a larger investigation platform. So this does the same things that I mentioned previously in terms of an AI copilot, but then it also carries out a lot of back office processes, such as writing a decision that can be ready to submit to your card processor or a chargeback being generated. You can also speak to an AI assistant for more complex investigation, which highlights many trends that many investigators tend to miss or are looked at by analysts. This is the summary of what we're building so far in the FCA Digital Sandbox. And at Trident, we're continually working towards building an AI tool or AI agents to assist banks and fintechs in really minimizing the amount of fraud victims they have and also the costs they face with this.
Great. Thank you, Trident AI. That was a very slick presentation. I guess we're going to bring in Zane and David now. Zane, David, can you hear us?
Yeah, I can hear you fine. Can you hear me okay?
Yes, perfect. All right, great. So I'm going to go out to the audience and just see if they've got any questions for you. Any questions out there? Okay.
Hi, I was just wondering whether your AI agent is capable of identifying potential responses that would be from coaching. So is that part of the model as well? So not just what they respond with, but how they respond and the speed at which they respond. Is that something it can cope with?
Yeah, so thank you for your question. I understand by coaching you mean if, let's say, they're part of an impersonation scam and they're being coached into making a particular payment, right? In that, yeah, we're trained. Sorry.
Yeah, yeah. So somebody's telling them what to say, basically, to your agent.
Yeah, so it's learning how to identify those patterns as well. If you consider it's looked at many different fraud cases and understood when customers being coached, they typically ignore particular warning signs. The same way a human investigator is trained on understanding that they, let's say, are being told, skip this warning sign or pass on this OTP. It would ask them, have you asked, are you on the phone to anyone? Have you taken any steps to identify who they are and where they're from? So those initial questions that would ask them, and any context specific ones that's learned over time from similar fraud cases. But yeah, coaching is one of the things it can do.
Okay, thank you. Yep, Adam.
Thanks. I had a question about, you mentioned that you didn't use the telco data. So just a question of why you didn't, and kind of related to that, are there any data sets you've used which aren't readily available, or actually is all of the data you've used kind of easy to get hold of and therefore kind of ready to go to market?
Yeah, thank you for the question. So we didn't use the telco data because, in the APP script data set, you only can access there are no SMS messages or, transcript. It's just like who called whom. So we didn't see, a huge, improvement for our models for just like this kind of simple use case. What would be maybe next step for us would be to simulate these kind of transcriptions and then use it to prompt it to create better user stories, to have like actually much better synthetic data set of like what actually happened. And in terms of the second part of the question, we use our proprietary methodologies for investigations and some previous cases that we use to train the LLM investigator, if that makes sense.
Yeah. Okay, thank you. Do we have any questions online in the chat? Okay, so I'm going to go back to the audience. Over to you.
I just wanted to ask a bit about, you mentioned 7 interactions in order to be able to dissuade a customer. What customer data was that based on?
So it was based on the data of the transaction history, the user actions, the previous conversations, the methodologies, and the real-time conversations.
Okay. Another question at the back. Yep, you got it.
Okay. So following the prior question, how will this handle overly aggressive customers who may not give you the best type of responses?
Yeah, so that is really common, right? You get customers saying, unfreeze my account, etc. It would map the organization's tone of voice primarily in saying, we understand you're frustrated, but we're doing this for your safety. A large part of which you're seeing across many neobanks now, they have a polite tone of voice. So we're training our AI agent to do the similar thing. So it does sort of do that polite pushback where necessary in identifying when the customer is being aggressive. The main important thing to add there is it will follow up then with the necessary question. Typically what you see right now is the pushback is to customer support agents whilst the customer is waiting for the fraud investigator. But what we have over here is the AI agent on the front line asking the same questions that an investigator would. So it's a better experience for the customer in being resolved sooner.
Okay. Let's see.
Yeah, hi. So I kind of wanted to ask, you mentioned that you use like an existing system to basically generate the alerts, and then once the alert is generated, you run basically this dialog simulation, right? So obviously the performance of the ultimate system depends on the first system. Question A is are these alerts generated by whatever institution you're working with, or is this something that you provide? And B, is the idea to broaden the scope of this first system with the idea that investigating whatever alert is relatively cheap, basically to maximize recall in the first system.
Sorry, we perhaps missed the second part of the question because there was a small delay, but the first question is like, yes, it is the output of the previous fraud detection models that is input into our models. We do not right now develop our own detection models, but exactly, I think the second part is like, yeah, we want to maximize recall by giving more investigation capacity. Then you can investigate more alerts and perhaps change the rules that you have in your detection systems. But sorry, maybe you can repeat the second part of the question because I think we didn't get unless I didn't answer it.
I think you answered it, but I have a follow-up. Is this system like deployed somewhere where there's no human in the loop?
We are still in the stage of having human in the loop. We give the advice of what you should ask the question, and they just approve it.
Okay, thank you.
Great, and thank you for joining us from San Francisco, which I'm assuming is a very unfriendly time of the day over there. So thank you very much, Zane. Thank you, David, and we hope to speak to you soon. Thank you for Trident AI.
Thank you.
Thank you. Bye.
Okay. 3 more to go. We're now going to go into the reg tech section. Just before I do, I did used to work in reg tech, so this is still a bit of a passion of mine. And the Digital Sandbox and the Tech Sprint program, they both evolved from reg tech. So it's still really close to our heart. That's essentially where we're getting most of our use cases from, even though they're broadened in scope a little bit. So I'm glad that we've still got a bit of a focus here. And now I'm going to invite to the stage, we do have Proof Marks, and we've got Marcus Soers.
Proof Marks a B2B2C SaaS platform made to protect the weakest link in cybersecurity. That's you, me, our friends, family, friends, everyone. Let's face it, how are people supposed to distinguish between this website and this website? The matter of the fact is that the tools that constitute our web framework make for a highly scalable market for lemons. Getting a lookalike domain is cheap. Padlocks are only providing people with a false sense of security, and content is as easy as copy-paste. It's best to visualize the size of the problem through a solar striker analogy. There were more than 2,000 banking copycat websites reported in 2023 in the UK, but since 84% of phishing websites are active for less than 24 hours, this makes for a more realistic visualization of the entire attack surface of a web that is ever expanding and ever changing, effectively making it a chase after ghosts approach. The reality is that existing solutions are ill-equipped to keep up with the agnostic nature of the web, providing us only with a false sense of security, as 90% of cybercrime includes a phishing element. UK Finance report gives us but a glimpse of the size of the problem, as the National Crime Agency estimates that reports account for less than 20% of the real numbers. Furthermore, against popular belief, losses from internet banking are larger in value than mobile banking, despite being smaller in number. Here, it is worth highlighting that there are phishing as a service toolkits being sold online for £160 a month, while, for example, selling a single credential of a verified login bank account can return a cybercriminal 20 times that amount on the dark web, with banks reimbursing their customers on average only 47% of the reported losses. This is getting expensive. The numbers for the US are very expressive: 52 billion in losses on identity fraud and 42 million adults affected in 2021 alone. These studies, sponsored by the US banks, show impressive increases year on year, but it is also important to highlight that for every dollar lost to fraud, the real cost to financial institutions is 4 times higher due to operational costs arising from fraud itself, and this multiplier is not even accounting for loss of revenue and other negative externalities, as we're still having a very limited perception of a much larger societal problem. Beyond all this doom and gloom is Proofmark, which provides trademarks the ability to claim and demonstrate their website's legitimacy. That goes to generate a market-driven allow list of domains that are federated to each organization and that is meaningful to each person individually as per their interests. Built on top of Trademark Clearinghouse, Proofmark is providing organizations and people with fair advantages over cybercriminals. Think of it as the other side of KYC, as a trademarked self-sovereign identity, a way for customers to know the website indeed belongs to the brands and organizations they want to interact with, not a cybercriminal. As Proofmark provides a paradigm shift that goes beyond domains and padlocks to make it seamlessly obvious if that URL has been authorized by the company the user intended to interact with or not. We're not doing this by education, but by design, as we built the missing tools to displace cybercriminals' ability to abuse the agnostic nature of the web. Putting it simply, Proofmark has designed out the flaws of the existing web framework to make cybersecurity human-centric, as registered trademark ownership rights power our hyper-personalized model of trust. For example, everyone in this room can tell the difference between a Lloyd's horse and a Ferrari horse, effectively making it possible even for my mom to tell the difference between a good website and a bad website. Proofmark makes it so much easier for end users to trust what they see, but also to seamlessly report ill-intended websites. Furthermore, our self-reconciling system allows us to ingest and reconcile block lists and allow lists at scale, where organizations, law enforcement, industry partners, and end users come together in a combined approach that is self-serving and self-enforcing. For example, if Lloyd's tells the system what's their digital footprint, we automatically know that the reported website is not, with no false positives or false negatives, while also speeding the time to action to a matter of seconds. Taking it one step further, we can feed the reported websites to Google Safe Browsing to prevent people from ever resolving malicious websites, even on their phones. More than market positioning, this is a list of potential partners and system integrators of our white space market solution. Imagine, for example, cybersecurity training awareness programs being run with Proofmark on top, also making cybersecurity a consumer product for clients, or brand protection services who are resellers of trademark clearinghouses to get Proofmark as a service in their existing customers' portals, not only blocking bad websites, but bootstrapping trust and legitimacy to the web. Beyond our ability to tap into existing budgets and service providers, as just highlighted, fraud managers specifically get allocated a budget to reimburse customer losses every year. And every year they need to ask for more to increase those budgets. But with Proofmark, if an organization is currently losing 40 million and we prevent 20 million, we take a cut of the losses prevented without an upfront cost, with a guaranteed 20 times return on investment for a 10 times better performance. As we go from this to this, Proofmark is literally changing the rules of the game, as our approach brings the power of many onto our platform, as well as massive network effects. To accomplish our permanent digital sandbox tests, we have used a sample of the domains available at the FS register. As discussed with the team, we believe there's room for regulation in this field by requiring organizations to provide a unique proof of legitimacy to their customers, thus complementing the industry existing best practices such as KYC, customer identity and access management, cybersecurity training awareness programs. As just demonstrated, Proofmark self-reconciling system beautifully integrates the goals of the FS register authorized firms against the unauthorized and cloned firms, productizing its ambitions in a seamless manner that consumers can make use of today. Furthermore, Proofmark platform is filling that empty space left between tech giant organizations, financial institutions, and regulators, but also between different departments within the same organizations, where customer identity and access management, cybersecurity, legal, marketing, and fraud departments struggle within their own silos, constrained by the narrow confines of their domains. With Proofmark, we're providing a one umbrella platform solution, as we are empowering each department to tackle their existing pains and problems through a white space market solution that goes from playing defense to playing offense simultaneously. While the browser extension will be free of charge to the end users, the total value added and impact that Proofmark provides will be far more than the sum of these parts, not only through obvious positive externalities between them, but by allowing people to feel safe as they go online. As I said, just because the internet is stateless, it doesn't have to be lawless. Everyone can already try the extension from the Chrome Web Store, and suffice to say that once we onboard 4 banks in the UK, Proofmark will effectively be protecting the entire population of the country, where we are here to create fair advantages in the fight against cyber criminals, as we would like to have you being part of our journey to shape our product and the World Wide Web for the better. Thank you.
Loving the Space Invaders analogy. I don't know if anybody picked that up. That was one of the first computer games I ever played in my existence on this planet. Not against real Space Invaders, just the computer one. Okay, so any questions for Proofmark and Marcos? Yep.
Hi there. So it looks very interesting. I was just wondering if you're planning to market as a consumer product, how will you ensure that your site itself isn't targeted by criminals sort of impersonating your own site?
Yeah, so our model of trust is really bootstrapping that trust. So again, we start with trademarks.
Yeah.
So maybe your question is there going to be an evil twin, right? Is that the question?
So if you're saying anybody can try it out and go into Proofmark,
try this extension working in a way.
But if as a consumer you want to go into that, but how will you know that you're looking into the correct Proofmark, the legitimate website?
That is the point of the model of trust, the B2B2C again. So the point is that it's brands themselves that are interested in protecting their brand online, saying this is the way for you to know that you are in my banking website or in my news agency.
So you won't have a consumer website called Proofmark?
No, this is really a B2B2C. So the end user, what happens is that if you go to our browser extension or to our website right now, you'll have a LO bar, and instead of that LO bar saying, be aware of phishing websites, say, make sure that you are on Proofmark website, and then you can go directly to download the extension.
Yeah, okay.
So this is a way as well for organizations to, instead of pushing the dirt down the road to say, like, be aware of phishing, is like, here's a way for you to know that this is not a phishing website.
Thank you.
Any other questions? Yep, Bryn.
Yeah, I was just keen to understand what you did within the digital sandbox and how you made use of that as part of your work.
Yeah. So the digital sandbox and the FS register allows us to get into a bit of an understanding of the authorized domains. This is where we say that there is space for regulation there. If you go to the FS register website and APIs, you'll see one domain per organization. This is the point where it's very hard to say what's right if you only know one website, and organizations have hundreds sometimes of them, right? So this is the point where our self-reconciling system can again provide information into that, because it is organizations themselves saying, this is my website. Now, this is the point where the organization has told us what's their website, and we can actually feed that into the FS register if they want it, because the organization is saying so. And this is also then going into marketing and advertising in Google and stuff like that, right? When they still don't know, they need to be FS registered, but then there's no registry of all of the authorized domains. So how can they know? This is again another place where the solution can shine, because it is the banks themselves saying, this is the authorized domain. All the domains that are pointing to this, or all the advertisements that are pointing to these domains, they can pass through. The ones that are not should not pass through the censorship of that, right? Of the fraud advertisements.
Okay. Any other questions in the room? Anything in the chat? No? Oh, okay, Denise.
Sorry, I was just looking on your website. It said you have to have a registered trademark with so if you're like a startup or a small business, will you be able to download your extension or be protected?
You can download the extension directly from the Chrome Web Store, Firefox as well in that regard. I think that your question then is about the requirement for a trademark. So the requirement for a trademark, as we say, is coming and being built on top of Trademark Clearinghouse. Trademark Clearinghouse is already regulating the entire domain space. The thing is that it is a chase after ghost of throat. It's trying to protect your brand of being impersonated in the domain. So in that regard, we are the other side of that. And that's why we're beautifully integrating into that. But yeah, our model of trust requires a trademark, because the trademark is the relationship that is built between the consumer and the organization. But as I say as well, it is the other side of KYC, because it's a matter of you knowing that when you go to a website, It is the organization that you're trying to interact with, and it is a way for the organization to prove to you, I am NatWest, I am Lloyds, I am the government of the UK.
Great. One more question.
Just to follow up on that, because fraud is a little bit like whack-a-mole. You whack it down somewhere and it pops up somewhere else. Does this just force fraud down towards people who don't have registered trademarks, like small businesses?
Potentially, yeah, but the amount of money there is probably much smaller, right? It's all about impersonating the big ones. That's where it is. That's your fishing pond, right? Where the money is. So, and then again, it is an hyper-personalized model of trust. So if someone's trying to impersonate an organization that you never heard about, why does it matter to you, right? If there is an organization in China that has a trademark that sells a product that you never heard about, how does it affect you? It doesn't. It's just really creating a divide between block lists and allow lists. And it's allowing us to create this gray area in between where suddenly you can raise your levels of alert. So right now you just have all the things that are being blocked that you never see, saying that everything else is probably true, but you cannot know that it's true. With this market-driven allow list, you know that it's true. You know that there's all the other things that you don't see, and everything that is in that gray area, including small organizations, you can wonder yourself, is like, is this legitimate? Should I be really putting my credit card details into it? And that will stop a lot of things, of course, right? The question is that really from a behavioral standpoint, suddenly you have a tool that allows you to know you are where you think you are, and it allows you to think or second guess whether you should move forward or not in that transaction.
Okay, great. Thanks, Marcus. And thanks, Prigmarks. Okay, we have 2 more to go. So we're going to go straight into Surfer Monkey. We are. So over to you, Surfer Monkey.
Good afternoon, everybody. My name is Alvin Al-Bakri, and this is my colleague Miguel Diaz, and we're here to present to you our regulatory compliant blockchain crypto mixer. We're just going to start with a 60-second video just to explain to you how our technology works.
Chain. It's a digital ledger where transactions stack up in blocks, no middlemen involved. Imagine effortlessly surfing on endless waves of data. But here's the catch. All this data is transparent. Anyone can see what you're doing as if your home had walls of glass. That's exactly why we need Surfer Monkey. Not only does it ensure privacy and compliance, but it's also user-friendly. No need for complex solutions like viewing keys or programmable privacy. Surfer Monkey transforms any decentralized application on any blockchain into a secure and compliant environment without smart contract integration. It's like fortifying your digital house with strong walls, ensuring total privacy with seamless integration through a simple front-end widget. Absolutely mind-blowing. Choose Surfer Monkey. Give your clients the privacy and compliance they deserve.
I hope you like that ad. Web3 lacks privacy and convenience. Users want privacy. Regulators want to assure the transactions are not being facilitated by money launderers or bad actors. Liquidity gets siloed off whenever users want to go into a private environment. This creates a problem. Most blockchains that go into a private environment add additional cost in doing that. So what's the purpose of having a blockchain without privacy? Users that go to privacy tend to have to prove that they're innocent if they use a crypto mixer. That's why we developed Surfer Monkey. Sorry, I'm a little nervous. That's why we developed Surfer Monkey, in which do not require viewing keys or programmable privacy. It is estimated that will be about $16.1 trillion put on the blockchain by 2030 in tokenized derivatives, RWAs, and institutional finance. That will be in the form of metaverse, in the metaverse. That will be in the form of banking solutions. That will be in the form of stocks, bonds, and other forms of derivatives. But this $16.1 trillion cannot be put on the blockchain if there is not a solution for privacy. That data can be mined by other actors and a corporation's competitors. SurferMonkey makes it so that you can conduct private transactions that a regulatory can have a visual access to and see those transactions happening. The user can also view those transactions. You have instant privacy through our simply integrated front-end widget. At this stage, I'm going to hand it over to Miguel to explain to you how our widget works.
Hello, everyone. Nice to meet you. So the product is very simple. It's just a front-end widget, 10 JavaScript parameters that are sent from the dApp to the widget. And this novel CK mixer, it's been on research for almost 2.5 years now, constantly improving. Also is patent pending. And we have here the oversight dashboard that allows the institution itself to see on mix their clients' transactions, and for the financial regulators to place the required accountability and financial forensics. In terms of the layers of our product, at the bottom, we have the mixing layer by the universal CK mixer, which allows to privatize any type of transaction. On top of that, we have the compliance layer with our decentralized anonymous compliance technology, patent pending, and has two main verticals, the traceability and the blacklist to block any sanctioned address of interact with SurferMonkey and any other dApps integrated to it. Then we have the application layer via the universal plugin, which allows to call any type of a smart contract, function, and payload. And finally, we have the users and developers layer, which abstracts the pain away to interact very simple with our protocol via simple widget. And now here we have a demo. So at home, I was playing at 2 times the speed, so it was faster. So it was just 1 minute. Now it's going to be 2 minutes, which means that you have an extra minute of hearing me speaking about tech, which is very nice. So here we have a user coming, interacting with their dApp, the parent window. The widget obtains the parameters from the parent window. Once this is unloaded, one object, the user sends the transaction to the blockchain. The asset gets logged into SurferMonkey alongside what the user wants to do, which in this case is just a simple transfer. Then here we have the input transaction with their hashes. And now we're going to go to another simulation of the system where we have a relayer, which is another off-chain entity that submits a zero knowledge proof. So in this part of the demo, we're simulating that the user creates the zero knowledge proof on their own browser, and then sends that zero knowledge proof to the relayer. And the relayer is the one that is going to submit that into the blockchain and thus giving the privacy to the user. Here we're creating the zero knowledge proof on the browser. Normally it takes 2 to 3 seconds. Here, because of the recording, it took around like 13 seconds more or less. It's important to note there are several security parameters in the backend to make it secure. So now the relayer is sending the zero knowledge proof to the blockchain. Now it gets settled, and once that transaction gets settled, then we're able to visualize the whole traceability of the output of the transaction, meaning what the user wanted, which in this case is just a simple transfer. There it goes. So here we have the whole transaction that happened, and there is no input address on that one. This one is the regulatory dashboard oversight. On the left side, we have the inputs. On the right one, we have the outputs of the transactions. And if you are not the regulator or an institution, you are not able to see row by row the transactions. Basically, you will see like all the rows mix, so you cannot apply any accountability or financial forensics. So the key takeaways from the digital sandbox were that we were able to finalize all our product with their feedback. Through their mentorship, we improved the dashboard. We obtained also where to obtain the data for the sandbox data of the sanction addresses of the blockchain, and also the guidance for the next steps to niche our market to RWA use cases. In terms of the team, we come up from a background of technology and also from business, regulatory engagement, and banking institutions. And yeah, that's it. Thank you, everyone.
I do have a question before we ask anybody else in the audience. Where's the surfer and the monkey? I was expecting to see some sort of surfer and or monkey. Right.
You're looking at two.
Okay. Who's the surfer and who's the monkey? All right, great.
That's how we met.
Nice. Now it makes sense now, I guess. All right. Is there any questions in the audience? Denise?
If you're applying like zero knowledge proof, would blockchain monitoring work to be able to actually do the forensics or the kind of the blockchain monitoring?
Are you talking
if
about
transactions? So if you're sending transactions, again, right now, one of the ways of monitoring and identifying suspicious activity is using blockchain monitoring solutions. So I'm not going to name any because there's a few. There's like
chain analysis.
Yeah, elliptic, TRM lab,
For example.
For example. So would it be possible to integrate that type of solution in a financial institution? Like, would it?
Yeah.
How
so
would that work?
What happens is that, so we have the regulatory dashboard on the top right. Here, the institution that flags something suspicious, let's say like one of you're a bank, you're a RWA house, and you see that one of your clients is doing something dodgy, and you're like, hey, what is going on here? I have no clue. I'm not a financial forensic. So then what you do, you give that transaction hashes, the input and the output, to the financial forensic team, which in this case could be elliptic, chain analysis, Hacken, one of those. Then they are the ones that will make the whole financial forensics proof, and then they will come to that institution and tell them like, no, it's clean, or no, it's actually very dirty. We need to tell to the regulators. So then here, the regulators can also access to the dashboard, and the institution can just be like, hey, transaction number 45 is being flagged. And here are the accountability proof by cryptography with zero knowledge proofs, and here is the report by chain analysis. So the next step is to put those add-ons into the dashboard.
You. Any other questions?
Thanks. Does that mean a bank would need to outsource their AML transaction monitoring to a chain analysis elliptic type company, or can they do the AML monitoring themselves?
If they're running the transactions through their own DApp, they will be able to also monitor the transactions.
Any more? Seamus, you awake? Is anybody in the chat? Okay, good. All right.
You explained it very good.
Okay, thank you very much, Surfer Monkey.
Thank you, everyone.
Thank you.
All right, so we are now down to our final demo. I'm now going to hand over to Adrian at OneID.
Is this working? Hi, so I'm Adrian Field from OneID. 13th unlucky slot, but lucky for you is the last one of the day. So here we go. We're a UK bank-based ID scheme, and we partner with banks to simply enable anyone that does online banking in the UK to simply and securely prove who they are online. We straddle open banking. We're regulated by the FCA as an AISP, and we're also certified under the Department of Science ID framework for a number of different use cases. Effectively, we upgrade a bank account to a UK certified digital ID using the DCIT framework. And you can create a new form of digital ID evidence through this process. And it's a very quick process to get through. So the problem we've looked at in terms of today's model of data sharing has a number of different weaknesses. So you don't know who you're collecting data from. The data is typically unverified, self-asserted, typos, etc. And you don't know where the data is going to. So typically issues of this, if someone has your stolen data, they can apply for a loan in your name. You wouldn't know anything about it because the data matches at the back end. Or for authorized push payment fraud, if the genuine person is trying to get through the process, you have an impersonator on the other side and they fall through it for it in terms of things like investment scams. So the project we looked at in terms of the digital sandbox was how can we look at investment scams? If I'm an independent financial advisor, how can I prove two things about myself? That I am who I say that I am, and that I have FCA permissions to offer investment advice. So imagine a scenario where I'm trying to find an IFA online, or someone's targeted me and said they're an IFA, and Aaron Oakes was the first IFA I could find on the register. There's two issues. How do I know it's a real person, and how do I know it's the same Aaron Oakes? I can look on the FCA register and see there's somebody on there with these permissions, and this is a real person who works for St James's Place. If you're in the audience, hi. But how do I know it's the same person that I'm actually interacting with? So the first API we looked at in the sandbox was our own. We use OpenID Connect, which is a global open standard for sharing ID data. We have a very simple open banking, typical AISP flow where there's four parties, the data subject, they consent with a certified third party, which is us. We can go to the bank data source, which is the second party. The customer authenticates with their bank, and we introduce a fourth party into this flow. So we enable that onward sharing of verified data through this process. The second API we looked at was the FCA register. So I can get an API key, I can call the register, I can find out there's an Aaron Oakes, he's on the register, that's good. I can see he works for St James's Place. But this still doesn't tell me that the person I'm interacting with is this same Aaron Oakes. I could also look at his permissions to make sure they're all up to date. But again, I don't know that this data belongs to that person. So this is what we're requesting from any trusted registry data source. If I could log into the FCA register and consent to share my data record, I could prove that I'm Aaron Oakes through the OneID service. I could then prove that I have these permissions, and those two things digitally match and they're verifiable. That enables me to solve the first problem of finding an individual online. The second part of this challenge is what if we introduce a corporate into this? So say I'm a director of a company, how do I prove I'm a real person? How do I prove I'm a director? And how do I prove that my company has the right permissions to offer the investment products? And if I do this in a digital way, I can prove this to an online platform and make that transaction much safer. So again, if I'm Craig Gentle, who's the CFO of St James's Place, if you're in the audience, hi. Again, I can direct people to Companies House register. They can look at the list of directors on there. But how do I know that if an imposter can claim to be any of these people? How do I actually verify that fact? I can look at the corporate record on the register and check that this company still has the right permissions. So again, Craig Gentle can prove who he is through our process. This is a UK certified digital identity, and it's an easy process to get through. And the recipient can get any number of data records depending on the scenario. The third API we looked at in the sandbox was Companies House. So similar process, anyone can get an API key. This is an open data set. I can get more data from Companies House. I can get a name and I can get a year of birth and a month of birth. So I've got a bit more data to do data matching, but this still doesn't prove that I'm the person that owns this record. So again, the theory was if I showed you this slide enough times, you'd remember it. But it's the same process. So if I can log into Companies House, authenticate with Companies House and consent to share just my data record with the fourth party, they know that that record belongs to me. I can also look at what permissions I've got, again, back to the FCA register. So same slide again. Here we go, consent to share some data, log into the FCA register and share my company permissions. This proves that I'm working for that company. So skip that one. So this is the common data model, consent, authenticate and share my data. With the move to beyond open banking into open data, open finance, we're recommending this as a secure way of sharing your data. All of the processes and technologies and protocols already exist through open banking to do this. The part that doesn't exist is the actual open data taxonomy and what does that data look like. but OpenID, FAPI, the secure way of connecting to parties and sharing data, is something we already have. We already have UK government standards around identity to enable this to happen. We already have the certification process of certified parties that are safe to consent to get your data. This will enable us to fix a number of the previous issues that we saw. So I can verify who the people are that are interacting with me. They can use smart data wallets, digital identity to prove who they are online. I can verify that through bank verification, through other sources of data. As a secure network, we do due diligence on the recipients of the data, so that cuts out the impersonation fraud. You block the fraudster off because they can't do FCA with my bank account, and you have verified customers get through the process. We've also looked at KPMG and Innovate Finance published a recent roadmap to open finance. We've tweaked some of the policy recommendations from that paper to match this flow. And that's it.
Just so happens we have Craig and Aaron in the audience, so if you'd like to stand up, please. I thought maybe at least there was a Craig and an Aaron in there. Are there any questions for Adrian?
Thanks very much. So, is this aimed at consumers to go into to actually prove who the IFA is, or who would actually be wanting to prove it?
So we're a B2B API product. So any corporate can put our button. We're essentially a button. We're a couple of web pages for consumer-facing stuff, and an API for the corporate. So it can be put in any digital journey. So in the social media scenario, it might be some platform that tries to recommend IFAs to people.
Yeah.
That platform could then verify that those people have that IFA permission in order for people to direct traffic to say, go to this site. This site has connected FCA register. They've verified who the people are, and they're a safe source of information.
Okay, because I'm just wondering from a consumer understanding point of view, and obviously the credibility of the actual. If you've got like a kite mark type of thing, then the consumer has to understand that, has to know what the kite mark is, and that they can trust it. So, what's the sort of credibility bit from the consumer point of view when the IFA says, "Look, he or the firm says, here go, this is who I am. I can prove it."
Yeah, sure. So the Department of Science, Innovation and Technology have something called the Data Protection Digital Information Bill going through the House of Lords at the moment. That puts all of this legal structure, all the digital ID framework into a legal structure, enables all the smart data economy stuff to happen. But as part of that bill, there is a trust mark within that. So there was 50 certified providers. We're one of them on the DCIT register. All of those certified providers will be able to use the new trust mark. DCIT already have a name for it. They're still going through the trademark.
So is there a plan to sort of promote this trust mark so people are aware of it?
Exactly. So this would be a UK government-led approach to tell people about this trust mark, to tell, look out for it online.
Okay.
If you can see digital ID providers with this trust mark, you know that's been through that certified process.
Okay, thank you.
Okay. Edgar?
Yeah, I have experienced the digital ID in Scandinavia, in Sweden and Norway specifically. Is this somehow similar to that concept, or what's the differentiator? Or because basically it works fantastic, but everybody has to agree on that. Basically.
Exactly. This was I was at Lloyds Banking Group before. I've been 4 years in this company. We were looking at digital identity. We looked all around the world at Bank ID in the Nordics. It's me in Belgium that uses banks and telcos. This is a solved problem in many other countries around the world. We don't have such a thing in the UK, which is why OneID was founded to build and solve just for this problem. So we're working with banks to say we now have a bank ID in the UK. Let's roll it out. Let's get to the corporates. Let's help fix some of the issues.
Good luck.
Thank you.
IFA in the room. What's the data feed like for the regulatory data from the FCA register? Do you query that continuously, or is it you query it once, it generates the DID, and then I'm home and dry for a period of time? Because authorities around different investment products get revoked continuously in line with regulations. So.
Yeah, so with the bank model, it's a real-time strong customer authentication and consent every single time. We don't really store the consent, so you get the liveness and the biometrics that FCA gives you. And the proof of concept, we're just doing a one-off seeing what's in the sandbox, what's available today. If the FCA had such a thing as a consent and authentication mechanism or a verifiable credential in the future, we would connect to that in real time. So absolutely a revocation list. It will be real time permissions each time.
Didn't realize we're getting homework. Do we have any other questions in the audience or in the chat? Okay, well, thank you, Adrian. And thank you, One ID.